A confirmation regarding the audio, please, guys. If you're able to hear me out perfectly well, kindly confirm the same. Thank you. So, hello, a very warm good evening to all of you, and welcome to Byju's Exam Prep IAS. Welcome to another session of climatology. In fact, one of the most important sessions of climatology, if I may say so, because today we are going to look into the portion of Indian monsoon. The phenomena of Indian monsoon, the factors which end up influencing the Indian monsoon, that is something that we are going to take a look at. Now, what is it that we had discussed yesterday? So yesterday we had discussed the basics of the ENSO cycles. That is, we started with the Walker circulation. Then we looked into what do we mean by a neutral phase of ENSO, what do we mean by La Nina conditions, what do we mean by El Nino conditions overall. So we looked at the overall impact exhibited by each one of them and the circulations which result, leading to the different types of rainfall patterns or dry conditions observed at both ends of the Pacific, that is the eastern as well as the western Pacific coastline. Then we observed the development of a thermally induced pressure zone even in the region of Indian Ocean, where we saw that on the both ends of the Indian Ocean you have the development of a high pressure and a comparative low pressure, which again ends up inducing a kind of a circulation in that area itself. And that is what we refer to as Indian Ocean dipole. And we looked at the different phases of Indian Ocean dipole as well, where Indian Ocean dipole has got a neutral phase, which intensifies into a kind of a negative phase, both of them being very detrimental for the amount of rainfall received in India during the monsoonal months. And also, you have the positive IOD, which significantly enhances the amount of rainfall received in India during the monsoonal months. After this, we took a look at the circulating pressure systems across the tropics and in the equatorial region, in being more precise, that is the Madden-Julian oscillation, where we saw that it has got two prominent phases. One is the enhanced rainfall phase, and you have two consecutive suppressed rainfall phases. So as it kinds of moves from west to east, you have different places experiencing that low pressure and high pressure. Wherever that low pressure of the MJO lies in whichever water body, chances are that there can be occurrence of tropical cyclones in those parts and in those water bodies as well. So that is how we looked at these atmospheric phenomena. Then eventually we looked at the causation and in fact the formation of jet streams. What are these jet streams? The different types of jet streams which are in existence, where we saw that primarily you have four permanent jet streams across the entirety of the planet. And these are the permanent jet streams, that is the polar jet as well as the subtropical westerly jet, existent in both the hemispheres. Now, with the shift of the pressure belts, the jet streams also end up shifting, that is to the north, to the south. It is with the shift of the pressure belts. Now, then we had initiated our discussion for the Indian climatic conditions and the various different factors which end up influencing Indian climate. That is something we were looking at. So, today, first of all, we are going to take a look at these different climatic conditions which exist and why is it that India experiences such a variety of climatic conditions, a vivid type of climatic conditions. So we had looked at the factors of latitudinal position of the country as well as the location of the Himalayas, which significantly turn out to be the rainfall providers in our country by blocking the moist winds coming from the Arabian Sea and Bay of Bengal region. So those winds are blocked, which leads to significant amount of rainfall occurring in this part. Now, these two factors we had looked at. Now we will take a look at the factors such as relief, factors such as altitude, and then eventually we are going to approach the portion of monsoons. Now, when we are going to approach the portion of monsoons, we are going to follow a unique strategy, so to say. Unique, why do I say so? Because that is not how you find it mentioned in the books. Any book that you open up, monsoons are mentioned in a fleeting glance, and there you will find that it is a kind of a mixture, a hodgepodge solution, where you have certain aspects of the monsoon mentioned along with the rainfall distribution, along with the factors which influence them. So the concept creation is something which you will not find to be existent during the reading of the books or any text. So what is the pattern that we are going to follow today is, first of all, we are going to discuss each and every factor which ends up contributing to or influencing the Indian monsoon. While studying all of these factors, for example, how is it that Indian Ocean dipole influences monsoon? How is it that El Nino influences Indian monsoon? The onset of Indian monsoon depends on what? How is it that the shift of ITCZ influences the Indian monsoon? So all these factors, first of all, we are going to cover those in detail, the 7 detailed factors. Once we are aware of those 7 detailed factors, then we will do the work of weaving a story around them. That how is it that from the initial stage to the end stage, how is it that the entire process of monsoon season in India unfolds? After that, we are going to take a look at what happens in the month of November, December. That is, from September onwards, as the monsoon starts retreating. What do we mean by the retreat of monsoon? What is the northeast monsoon which sets in? What are the western disturbances? And then, once we are done with that, we will be discussing few of the previous year questions before moving on into the global climatic classification and reading of the world climate, part of world geography, very much so. Okay, so that is what we are going to cover today. So we start with, first of all, the factors which end up influencing India's climate. So we had looked at latitudinal position of India, and we had looked at the role of Himalayas. Then comes the relief features. What do we mean by relief features? So any kind of topographical feature which exists in the form of a barrier, like a plateau, like a rift valley, like a hill, like a mountain. So those are included under relief features. Now, across the country, you have various different relief features. Now, all these relief features, they carry out one basic work, or in fact, couple of basic works. So the role played by the relief features overall, here you can see it affects the temperature, air pressure, direction and speed of wind, and the amount and distribution of rainfall. So in a way, it provides a direction for the wind flow. Okay, it provides a kind of a direction, that in which direction should the wind be existent or the wind is flowing. We'll take the example of that as well. For example, this is very apparent in the cases around the region of the Western Ghats, in some portions in the northern part of Western Ghats, as well as in the northeastern region. This is a feature which is very prevalent, very prominent. Then after that, also offers a physical barrier. Which kind of rainfall will the relief features cause? Which kind of rainfall? We have looked at the different types of rainfall which exists. So when we talk about relief features, what kind of rainfall do they occur? Do they lead to? Very good. And cause orographic rains. Now, significant majority of the country ends up receiving rainfall precisely because of this orographic feature. Significant portion of the country, they end up receiving rainfall because there is one or the other orographic feature providing relief rainfall or orographic rainfall in some part of the country. We'll take a look at with the help of map as well. But overall, I hope we understand that whenever we talk about any kind of a mountainous feature, so here, as the winds come in, the winds are forced to rise up. As the winds rise up, they lose their temperature, they start to cool down. When they cool down, the water vapor present in them undergoes a kind of a condensation, causes humongous amount of rainfall, right? And the other side, the wind will be dry. And this will be warm, right? Why is it that the wind will be warm here? If you have to mention the atmospheric phenomena, why the wind will be warm in this part, what do you think? Beautiful. It is adiabatic compression or adiabatic heating. So accordingly, this is what is referred to as the windward side of the mountain. And this is what is referred to as leeward side. Mandeep Singh Saini, why cyclone in Indian Ocean travel from west to east? We'll talk about it today. Don't worry. I'll tell you all about why in India you have cyclones in certain seasons. Why do the cyclones exhibit a movement in a certain direction? Everything will be talked about. Everything will be dealt with. Do not worry. Have patience. Okay. So this is what orographic rains, the different types of rains that we had studied. So we had studied 3 different types of rainfall: convectional rainfall, orographic rainfall, and frontal rainfall. Orographic rainfall is the one caused by any physical barrier. That is the orographic rain. So here, in the regions such as Western Ghats, the physical barrier which is offered is even more drastic, because we know that Western Ghat is a kind of an escarpment of feature. Escarpment means there has been faulting which has happened. So you have very steep wall-like slope on one end. Across the region of the Western Ghats, you will have this to be very steep, almost wall-like. So as a result of it, you have incredible amount of winds which are directly pushed up. And as these winds are directly and continuously pushed up, it will lead to significant formation of cumulonimbus clouds, very heavy rainfall, thunder, and lightning. That is where, even wherever you have various different relief features, the type of rainfall varies depending upon the characteristics of those relief features. Okay? Now, the windward sides of Western Ghats and Assam receive high rainfall. Even in the case of Meghalaya, we have the region of Cherrapunji and Mawsynram. They end up receiving high amount of rainfall, whereas the southern plateau remains dry due to the leeward situation along the Western Ghats. So always understand that whichever portion lies in the leeward side of a mountainous feature, it will mostly be dry, because by the time that the winds are able to reach the leeward side, they already become dry and warm. Okay, so they already end up becoming very dry and very warm. Now, that is why all the regions in the leeward side, they are drier. Now, let us take a look at it in this rough map of the country. Let us try to understand how is it that relief features, they determine the rainfall received in the entirety of the country. So here, obviously, you have the Himalayas. So you have the 3 ranges of the Himalayas. In fact, not only the Himalayas, you have in some portions the Trans-Himalayan portion as well. Here you have the Karakoram, Zaskar, Ladakh, Kailash. So these are the topographical features that you come across. Here you have Garo, Khasi, Jayantia, Mikir, Bareil ranges as well. Right? Now, when we talk about monsoon season and start following it very logically, okay, observe it very logically, everything will be understood. So when we talk about the monsoon season and the rainfall that we receive during the monsoons, Then, if I ask you, what is the source of this rainfall? What is the source of this moisture which is brought by these winds? After all, that moisture causes rainfall. So, what is that source? Very good. You have broadly the Arabian Sea and the Bay of Bengal, but overall, the moisture is carried all the way from the region of Indian Ocean, but broadly, moist winds are brought by the region from Arabian Sea and Bay of Bengal. Okay? Now, understand how it influences the amount of rainfall. So we will study about how the wind gets into formation, how the wind comes into existence. But when you have moist winds approaching like this along the Western Ghats, so first of all, on the western side of Western Ghats, this lies on the windward side. So all these areas starting from the Kerala coastline, they will be receiving a lot of rainfall. Huge amount of rainfall will be received here. Okay? Why? It is on the windward side. On the leeward side, these regions will be dry. Isn't it? These regions will be dry. That is why central portion of Maharashtra, other than Pune and Nashik, if you look at the central portion of Maharashtra, the northern part of Karnataka, the region of Telangana, the northwestern part of Andhra Pradesh, or in fact, western part of Andhra Pradesh, these are the areas which typically receive lesser amount of rainfall. Why? Because they are on the leeward side. Then here, the winds, they will go here, right? Now, when they come across the region of Rajasthan, look at the alignment of the Aravallis. Here, Aravallis will offer a kind of a resistance only in this portion, that is the southern portion. Otherwise, the Aravallis will be parallel to these moist winds. They will be parallel. Now, if any mountainous feature, if any kind of a topographical feature is parallel to the moist winds, will they be able to cause any rainfall? Absolutely not. That is why the western part of Rajasthan remains absolutely dry, because there is no orographic obstruction causing or forcing the moist winds to drop their rainfall there. Now, because these winds are not stopped here, had the Aravallis got a different alignment, let's say the Aravallis would have been, let's presume the direction of the Aravallis would be like this. In that case, the entirety of Rajasthan would not have been a desert. It would have been very green, because the moist winds would have been stopped here and it would have caused rainfall. But in that case, the region of Punjab and Haryana, they would have been dry. Isn't it? Because that would have lied on the leeward side. So that is why alignment of the Aravallis is very important to determine, and is the important factor which leads to desertification in western portion of Rajasthan. And please understand, Rajasthan has not always been a desert. That has been a very recent phenomena. When we come to Indian desert, we'll talk about it. So these then go forward, and they basically, again, they experience the Himalayan ranges. The Himalayan ranges will also lead to occurrence of rainfall, causation of orographic rain in this area. Isn't it? On the northern side of it, slightly lesser amount of rainfall, drier conditions. Again, the southward face, whatever moisture is left in the winds, it will bring some rainfall, right? In the second ranges, again, little rain, little and very little minimal amount of moisture which is left, that will be brought by the fourth range, third range rather. Then the Zaskar Ladakh, they will extract the remaining amount of moisture. So now the winds which have crossed all these four ranges, will that wind be rich in moisture or very poor in moisture? What do you think? the winds which have crossed the ranges of Himalayas, they have caused orographic rains. Will they be rich in moisture or poor in moisture? Significantly poor in moisture. That is why here in the region of Ladakh, that is a cold desert. Why cold? Because latitudinally it is situated around 37, 35, 37 degrees north. That is significantly in the subtropical region. And it also has got an altitude. That is why it is colder. But there is no rainfall in that region. That is why it exhibits a kind of a desert-like characteristic. Otherwise, look at the nearby regions of Kashmir, the Jammu region. Look at the region of Gilgit-Baltistan. These are very green, almost at the same latitude because they receive some amount of rainfall. Ladakh does not. That is how orography influences. Another factor, when we talk about the Bay of Bengal branch of Indian monsoon, as the winds they enter, first thing that they experience is an obstruction in the form of the Himalayan mountains. Now, the obstruction is so immense, especially in this portion of the country. If you go to the region of Sikkim, and whereby nearby you have Bhutan, etc. So there, it is not like what you observe in the region of Haridwar, Rishikesh, Uttarakhand, Himachal, and Jammu and Kashmir, where you observe that, okay, there are three ranges which are spread apart and it is wide. In this region, the mountains are very narrow. Immediately, you have very tall peaks which start rising up. So while this region receives rainfall, but there are so much amount of winds coming in, the wind, some part of the winds are diverted here and here. Now, let us pay attention to the wind which has entered into northeastern region. The northeastern area, observe that. There you will find that there is an entry point for the wind, but there is no exit point for the wind. There is no place from which the winds can exit this. So what happens? The winds, first of all, they keep on hitting this region continuously, causing endless rainfall in Cherrapunji, Mawsynram. Whatever winds they pass through here, they keep on hitting one mountain after the other, causing continuous rainfall. This is what we also refer to as a funnel effect. A funnel effect is what? Funnel is what? Funnel is something like this. That is a funnel. So anything which comes in from any direction will basically be directed through here. Similarly, in the northeastern region, any wind which does enter through, it has got no exit than to bring rainfall in the entirety of the area and eventually find an exit path. So that is where the northeastern region is able to receive very high amount of rainfall. So that is the role of orography. Also, another feature. From here, the winds in between the Vindhyas and the Satpuras, they find a kind of an opening in the form of the Narmada Rift Valley system. So these winds, they are able to quickly enter through this Rift Valley, moist winds. They reach the portion of central India and they cause significant amount of rainfall in the region of Madhya Pradesh, Chhattisgarh, some parts of Odisha, and that is why those areas are much greener, right? So that is how it is able to, the relief features are able to influence the rainfall received in India. Okay, I hope that is something that you will keep in mind almost as long as we talk about the features of advancing monsoon. So all these features we shall be discussing again. So thereby we see that relief plays a very important role, a very major role in contributing to the climatic variations that we experience in India. Then comes land and water. Okay. Amit, write what? What do you want me to write? This is written here, the relief features and the role. Okay. If you want me to write that how in the region of Western Ghats, which part of the Western Ghats receives rainfall, which part does not, Aravallis why and does not, you'll find that in the additional reading material. Okay. And otherwise, now you have the recorded sessions of the classes as well. Use that, write it on your own. It will help you in a better way. Okay. Now we come to the distribution of land and water. What do we mean by this? Now, India's location is so unique in a way that we have water body which surrounds us from three sides. Arabian Sea to the west, Bay of Bengal to the east, and Indian Ocean to the south. That is why the region is referred to as the Indian Peninsula after all, isn't it? Peninsula is what? A land mass which is surrounded by water bodies from three sides. Now, this positional or locational aspect of the country has got a significant role to play in influencing the rains in India. In fact, one of the first models which was postulated for Indian monsoon during the 1700s, that was when the first model of Indian monsoon was postulated. It was said that, look, Indian monsoon is very simple. During summer season, the land will get very heated up. When the land will get very heated up, comparatively, water will be hotter or colder. Comparatively, during summer season, water will be colder, isn't it? So here, land will develop a low pressure, water will develop a comparative high pressure, and that is why you'll have the wind action causing rainfall. This was the first explanation of monsoon. While over a period of time we understood that yes, there are other factors controlling and manipulating the impact, but here let us try to understand nonetheless what is the role that the land or the water body surrounding us from three sides, what is the role that they play. So the first role, if I have to talk about what is the first role that they play here, Biswajit, why the wind bend in the region of Narmada? They don't bend, Biswajit. In the region of Narmada, the Rift Valley provides a passage to the wind movement. That is where they escape through. So first role, they provide moisture-laden winds to bring rains. Across the country. Okay. Then, second, provide moderation to the coastal climate. We have looked at that how the regions across the coastline, they end up experiencing a moderate type of climate, whereas when we talk about the regions in the interior, they experience extremities of climatic conditions, very cold winter, very hot summer, whereas across the entirety of coastline you will find moderation of climate, isn't it? So that is why provide moderation to the coastal climate. Annual range of temperature in coastal climate is high or low? It is low. Range of temperature means variation between summer and winter temperature. Okay, so the annual range of temperature is low. Now here, there is a relative high pressure created during the summer season. Where? In the water body. So, relative high pressure builds up over the water body. Right? Driving winds inland. Okay. So this is the influence played by the distribution of water. And that is very important. In fact, if you have to write this in detail, see, these are the 3 points that we have discussed. Let's suppose you face a question in the exam that what are the factors which influence Indian climate? And you have to write 150 words in that. So obviously, in all of these, you will write 4 or 5. In all of these points, you'll write 4 or 5 sub points, etc., and you'll be done with it. But let's suppose you get an individual question that how does water body around India influences India's climate? What are the additional points that you think you can write? Any additional point that you can think about? Indian Ocean dipole, very good. Bay of Bengal. See, Mascarene High, Nitesh, is very much in the southern Indian Ocean, right? So when we say water surrounding India, that won't come into play. Harihar and Pratyaksh, very good. Please do mention the impact of cyclones. The cyclones that we experience in the coastal areas, those cyclones develop in these water bodies only. Had there not been the presence of these water bodies, India would not have experienced such frequent occurrence of tropical cyclones, which cause so much destruction and devastation. So there you get an opportunity to talk about this as well. Okay. So what I'm trying to convey here is there are going to be certain types of questions from areas that you have studied before, but it would require a greater amount of application. That will only happen if you are able to interrelate everything and look at the broader picture. Think about it yourself as a third person. You're looking at the broader picture that, okay, this is what Bay of Bengal does. This is what Arabian Sea does. Not only does it drive the moisture, it moderates the climate. It leads to occurrence of tropical cyclone, high pressure condition, driving the wind pattern. All those you can describe in significant detail, and thereby you'll be able to score good marks. That is something which is very much required for your mains exam. That approach is very much required. Then we come to the role played by altitude. Now, various parts in the country, they are not all placed at the same level, at the same height. Many of these have different heights, right? Few places are at greater elevation, few of the places are at lower elevation. So obviously, we do know that with the increase in height, the temperature reduces, isn't it? We know the normal lapse rate. Normal lapse rate is how much? Is 6.5 degrees Celsius per kilometer. Okay? Good. Means you guys are revising. Very happy. What is the dry lapse rate, guys? Nice. No, it is not 5. Dry is 10. Wet is 5. Okay? Always temperature will change more drastically when it is dry. Now, so if you take a look at various places which might be situated at the same latitude, but they will exhibit a difference in temperature during the same time of the year because the altitude is different. For example, take the case here, the very famous example of Agra and Darjeeling. They are located at the same latitude, but elevation of Darjeeling is 2 kilometers above sea level, whereas that of Agra is only 171 meter. So that is why in Agra in January the temperature is 16, but it is 4 in Darjeeling. Same is the case with Ooty as well. Take the case of Ooty. Ooty is almost situated along the similar latitudes as you have the other nearby regions around, for example, Chennai, for example, take areas in Kerala, even in some nearby areas in Karnataka. The latitudinal position is not very different, but the temperature is significantly different. Why does that happen? Primarily and purely because of the altitude, right? That brings in a change in temperature. So what are the factors which influence India's climate? Latitudinal extent, Himalayas, then we have the relief features, the other relief features across the country. Then we have the presence of land and water. The distribution of land and water is very unique. And then we have the factor of altitude. Together, all of these should give you the ability to create 250 words easily. And I have seen a few of your papers. I do get a chance to look at few of the papers. Few of you are writing very good answers, but you are unable to draw any image there. Even a rough image that you can draw in 30 seconds to 45 seconds, it need not be perfect, but a rough image, if you are able to draw, that in itself will create a huge impression on the examiner. See, it is not a competition in the mains examination. It is not a competition that you will score 15, someone else will score 2. No, everybody will be playing around in the same range. So it is about gaining an advantage of 1.5 marks every answer. If you gain an advantage of even 1 mark every answer, that means in one paper, you gain an advantage of 20 marks. 4 papers put together, 80 marks only in general studies. So please draw the relevant diagrams. Any rough diagram that you draw the relevant diagrams. Okay? So here, when we talk about it, now we come to Indian monsoon. And we first of all look at the various different factors which influence Indian monsoon. Okay. So first of all, we shall be taking a look at these individual factors. So for example, the differential heating and cooling of land and water. See, all of these, they associate with the very basic phenomena of environment, or rather climate. But all of them, when they come together and have that interplay, that is what creates a very complex phenomena in the form of monsoons. Individually, all of them, they are very simple phenomena. For example, differential rate of heating and cooling. We have studied in the initial portion of climatology that land will get heated quicker, water will be comparatively colder or cooler, and vice versa during the winter season. This is one of the major drivers. This is what pushes the shift in the position of the ITCZ, where during the summer months, the ITCZ shifts north and comes on top of India, the northern part of India. Now, ITCZ, what does it do? It drives or attracts the tropical winds. Can we not say that trade winds, they are attracted to where? ITCZ. If ITCZ is lying over India, it is going to attract winds from all over. So that is when the winds come over to India. Then when the ITCZ moves back, winds move away from India. Seasonal reversal, that is what is monsoon. Then the role played by subtropical westerly jet stream. This is very relevant, very important for onset of monsoon. Right? I hope that we remember what we discussed yesterday, that subtropical westerly jet stream gets divided into two parts. Northern branch, southern branch does not allow the air to mix from different regions. So this is very important in terms of bringing the onset of monsoon. Yes, Pratyaksh, correct. Then heating of Tibetan plateau and the generation of a temporary jet, that is tropical easterly jet stream. This is a temporary jet. Temporary jet. Okay, so that again is important for strengthening the monsoon. Not so much for driving the basic phenomena, but strengthening the monsoon system. Then you have mascarene high. This can be referred to as the driving high pressure, which controls the monsoon winds. So think about it in the sense, the electricity supply that you get in your house, right? You can have various factors which can influence the quality of supply. For example, whether there is any of your neighbors stealing electricity from your supply, that will reduce the supply at your house. Whether you have someone having many gadgets, electronic gadgets running them, that will also lower the quality. All of this is going to influence the quality. But for that electrical supply, there is a main switch generally outside or downstairs. That mascarene high is the main switch. Think about it. That is how important this mascarene high is. If mascarene high is strong enough, the entire monsoonal season will be very strong. Then you have the influences of ENSO cycles as well as the Indian Ocean dipole. So that is what we are going to study one by one. Each one of them we are going to take a look into. Starting with the heating of the landmass. So basically, this is a simple process. So when we talk about the months, start from now itself. It is the month of March. We have recently crossed the portion of equinox, that is 21st March has recently passed by. That means we are coming to a time of the year when the location or the position of the sun is coming more to the north, right? We are coming to that part of the year. The temperature, whichever part of the country you are living in, you would already have started experiencing warm weather conditions. Temperature in most of the parts of the country, you would already have experienced a temperature of 30 degrees plus. In certain areas, already there is temperature in the range of 35 degrees plus. That is something which is happening. By the end of April, this will further increase. In the first week of May, you experience, excuse me, in the first week of May, you will easily be able to experience temperature in the range of 35 plus, 40 degree plus, right? In whichever part of the country, unless and until we are living in the region of Himachal Pradesh, Uttarakhand, the high altitude region, or Jammu Kashmir, Ladakh, or few of the northeastern states, unless and until we are living there, the entire country experiences such high temperature, especially during the months of April, May, June, July. Right? Now, due to this, there is significant amount of heating of the land because of such high temperature. Land develops low pressure. Comparatively, nearby water bodies, comparatively cooler because land gets hotter much faster. Because they are comparatively cooler, you will have a comparative high pressure develop in certain areas. Due to which these can drive local wind of sorts, causing rainfall in certain parts of the country, right? So, basically during the summer season, the land becomes extraordinarily hot. The nearby water bodies are cooler in comparison. As a consequence, cooler moisture-laden winds from these water bodies, they hit the land mass and they cause rainfall, right? That is when these moist winds they come, they get heated at this low pressure, the winds will rise up, they will form cumulonimbus clouds. That is why during these months, when you receive rainfall, especially during this month, next month, when you receive rainfall, you will generally observe occurrence of very heavy thunderstorms and darkish clouds will develop, as in cumulonimbus clouds will be more prominent during these months. Okay, that is because the air is rising up and then causing rainfall. Convectional rainfall is being caused in these areas. Okay, then due to the heating of the landmass, we also observe the movement of the ITCZ. ITCZ, we know, is the thermal low pressure. Around the region of equator, ITCZ is the thermal low pressure. Thermal low pressure. Now, thermal low pressure means those areas are significantly hotter than the surroundings. That is why the ITCZ is lying there. Now, this ITCZ ends up shifting between the summer and the winter, owing to which is the area which is experiencing maximum temperature. So, while in the month of January, when you have winter in the northern hemisphere and summer in the southern hemisphere, that is when you observe the ITCZ to lie here, especially in the case of Indian Ocean. But here, during the month of May, June, July, look at where the ITCZ is. It has moved over because of the heating of the landmass. Let us understand the impact of it. So here, first of all, the equator. And then let us think about the ITCZ. So initially, the ITCZ will be lying where? During the month of November, December, or let's say even January, February. That is when the ITCZ will be roughly, let's not concentrate on the region of Africa. Over India, if you will consider, ITCZ will be here in the month of January. Why? Because it is summer in the southern hemisphere. So that is the region which is more heated. February onwards, as you have the movement of the sun slightly coming back, March is when the sun is over the region of equator. Slowly and steadily from now on, you will observe the northward movement of the sun. Now, as the sun is moving northwards, significantly, the ITCZ will also start moving northwards. Right? This might be the position in first week of April itself. Now, if the ITCZ is here, what will be the pressure condition across the region of Bay of Bengal and Arabian Sea? So, wherever the ITCZ lies through or passes through in these water bodies, won't that create a kind of a low pressure over these water bodies? Isn't it? This ITCZ will create a kind of a lower pressure over Arabian Sea and Bay of Bengal. That low pressure can develop certain disturbances, right? That is why since April onwards, you have the development of these disturbances which are observed in both Arabian Sea and Bay of Bengal. If the temperature of either of these water bodies is high enough so that that low pressure can be capitalized into a circulation, if the temperature is high enough, it will easily develop into a cyclone. Otherwise, this ITCZ continues to further move up. Let's say this is the location of ITCZ around 25th of April. Let's assume by this time the water body has heated up and you had a pre-existing low pressure which the ITCZ had left behind. So here, let's assume one of those low pressures, they develop into a cyclone. But before that, another concept. Before we come into cyclones, another concept. Now, when you think about the ITCZ, I bring you back to the tricellular model. When you think about the ITCZ, generally in tricellular model, what do we observe? You have the winds from the tropics, they come in, they rise up, they cause rainfall around the region of ITCZ. Isn't it? Again, they rise up from the subtropical high pressure. Isn't it? So, when you have the ITCZ, ITCZ has or attracts trade winds, right? Now, here if you observe, the trade winds, basically they will be driven towards this ITCZ. If this is the ITCZ, the trade winds will be driven towards this ITCZ. Now, what about in the case of the northern hemisphere, the trade winds will come like this. What about the southern hemisphere? The southern hemisphere trade winds, they will be moving like this. And in the month of April, May, June, July, what is the season in southern hemisphere? Summer or winter? Very good. It is winter because it is summer in northern hemisphere, so it is winter in southern hemisphere. Now these trade winds, they will cross the region of equator. As they cross the region of equator, the Coriolis force will bend them to the right. So these trade winds, they bend to the right. Now what is their destination? Destination is ITCZ. They want to reach ITCZ. Okay? Meanwhile, while this has been happening, let's assume that due to higher temperature observed in these areas and as the ITCZ has been passing by, let's assume here you have development of a cyclone. Now this tropical cyclone, that will be carried by the trade wind. We can say that this cyclone will be driven by the trade wind. Now, what is the direction that this cyclone will follow? It will also be driven by the trade winds towards the ITCZ. So it will also start moving towards the ITCZ. But along the way, it will also be bending slightly to the right. Where does it hit? It hits the region of Maharashtra and Gujarat coastline. That is why those you who are asking that how does cyclone travel from west to east? This is why, because that is the existing wind system in that region. That is why the month of April and early part of May, these are considered to be the hotspots of cyclones, because these are the months when you have the occurrence of cyclones, right? Now, there are other seasons for cyclones as well. We'll come back to it later in the module. So here, the ITCZ is shifting north. This is attracting winds. Now, what in general is the direction of the winds? Direction of winds towards the ITCZ. Direction of winds is what? Is southwest to northeast. How trade winds bend after crossing equator? Because of Coriolis force. When they cross equator, see, where is it that the trade winds have to go? Trade winds have to reach ITCZ, isn't it? That is where the trade winds have to reach. That is their destination. That we have to reach ITCZ. So how does it happen? So if the ITCZ is here, the trade winds, while in southern hemisphere, they are bending to the left. As they cross the equator, now they will be bending to the right. Owing to the Coriolis force in the northern hemisphere, they will be bending to the right. That is why the general direction that you get, the general direction is southwest to northeast, right? And winds, we know, winds, we do know that winds, they do move or they are named after the origin direction. That is why these winds, they are referred to as south west winds. Anil, these are the trade winds, my dear friend. This is the northern trade wind. This is the trade wind, the southern trade wind. This trade wind, that is from the southern hemisphere. southern hemisphere, this is the trade wind. This trade wind crosses the equator, and that is when it deviates to the right. All those who are getting confused at how is that the winds are getting deviated to the right, that is because of Coriolis force. Now, if there is confusion that, okay, but equator, the deviation should be zero because Coriolis is zero, fair enough. At around 5 degrees, till 5 degrees north and south, no deviation. But what after 5 degree north? After that, so they will bend. After that, they will experience a deviation to the right, won't they? So that is why they are deviating and forming this kind of a direction. Okay, let's not have it 90 degrees deflection. Let's have a lesser deflection only. But will you not agree that there is going to be a deflection here? That basic is something that you will agree. Let's assume that it is deflecting only like this. If you guys are fine with this deflection, if this works, right? Okay. So this works for now? Good. But when I show you the real image of the winds, that will be very different, but nonetheless, as long as the doubt is cleared. Then why the cyclone move right? Shivani, if right now in this situation, a cyclone is formed, where will it go? If a cyclone is formed here, where will the cyclone go? Won't the cyclone be carried away by the trade winds? They will be. Or should they wait that no, in the PPT, everybody has studied that I only move from east to west. So let the east to west winds come, only then I will move. Will they wait for some time? No. Whichever winds are present at that point of time, that is how they will move. Isn't it? Before shifting of ITCZ over India, Arabian Sea and Bay of Bengal will have a comparative high pressure? Yes. Okay. So this is clear. If their destination is ITCZ, so why don't they meet the same at Africa? How can you expect a wind system here, which is developing here, Abhishek? Why will it go and meet here in Africa? Just because it is easy to draw on the map doesn't mean that this will happen across tens of thousands of kilometers as well, right? So why will they go towards Africa? Even in Africa, the ITCZ is shifting to the north. Even in Africa, if you look, this is where the ITCZ is, this is where the equator is. There's a significant amount of gap here, isn't it? So that is why, as the winds, they are coming from southwest direction, and they are coming after bringing or after moving through tens of thousands of kilometers across oceans. That is why these winds are significantly moisture laden, and they bring rainfall during the monsoon months, and that is why we refer to them as southwest monsoon. Southwest monsoon. Okay, that is why they are referred to as southwest monsoon. Now, the ITCZ is the zone indicating low pressure in the tropical region. It is in this zone that winds from both the tropics, they converge. ITCZ moves to the north and south with the apparent movement of the sun during the monsoon months. That is after a prolonged summer season. The ITCZ passes through the northern part of India. This ITCZ attracts winds all the way from southern subtropical high pressure belt, because you will have the subtropical high pressure belt in southern hemisphere, northern hemisphere as well. Now remember, we had discussed earlier that you don't have the existence of a long pressure belt of sorts, rather you have pressure zones. If you recall that, we had discussed that you have the pressure zones, the high pressure zones, the low pressure zones, which drive and attract the winds. So that subtropical high pressure zone lies in the southern hemisphere, which is driving the winds all the way from the southern hemisphere to the northern hemisphere. Look at the satellite imagery of the winds. Okay, so if I was drawing incorrect, fair enough. Look at the correct depiction of the winds. Look how these winds, they are bending to the left in the southern hemisphere. When they cross the equator, they bend to the right. Observe this. Do you have winds going over the region of Africa? No, you don't. Right? So the coastal Africa will receive some amount of rainfall, but otherwise the winds, they don't go to Africa. Why will they go to Africa? Right? So I hope this is something which is clear now, right? How the winds move and why the winds bend. The winds bend due to the Coriolis force in play. Okay? Rahul, it is not a cyclone. This, what you see, this portion that you see, this is at this point of time, southern hemisphere generally will have a kind of a circulation of winter season. So here what you see is an anticyclonic cell. This what you see is anticyclonic cell. Why and how? Because look at the winds emerging from that high pressure or from that region. Look at how the winds, they emerge and they move in all different directions, right? So here that is an anticyclonic cell. This is a region of high pressure. This is a zone of subtropical high pressure. High pressure zone. This is present around the region of Mascarene Islands in the southern hemisphere, and that is why this subtropical high pressure zone, this is also what is referred to as the Mascarene high pressure. Mascarene high pressure zone, or simply put, only Mascarene high. Here also you will observe, look, that the winds are generated from here. The winds are driven from this high pressure. Okay, so that is how the winds behave due to the shifting of the ITCZ. Then comes the role of the subtropical westerly jet stream. Now this is very important in terms of causing the onset of rainfall. Now let us understand a bit of the nuance here, and let us assume that the basic is clear. Okay, so the monsoon, if I have to ask you the basic, that in one sentence tell me, why is it that India experiences monsoon rainfall or the monsoonal season? The answer will be pretty clear. That look, during the summer season, there is prolonged heating of the land, creates a low pressure due to shifting of the ITCZ. And nearby areas are high pressure, so they push in winds. These winds are moisture laden, they bring rainfall. Fair enough, that is the monsoon phenomena. But then, here, the heating of the land will happen every year. Every year during the months of April, May, and some part of March, you experience extraordinary amount of heating. Every year, around 21st of March is when the sun's movement starts moving towards the northern hemisphere. Every year, on 21st of June, you have the sun directly over the Tropic of Cancer. Every year, during the 21st of December, you have the sun over Tropic of Capricorn. So if the sun is so disciplined that you have the presence of sun on the exact same date, if you have the other factors are generated because of solar insolation, that is ITCZ, etc., also shifts due to the heat and the temperature. Why is it the case that every year we don't experience the same rainfall? Also, more importantly, have you ever thought about it? Why is it the case that when we talk about onset of monsoon, in certain years we experience the onset in 27th of May, as was the case previous year, or first week of June, as was the case year before that. Even this year, after a month around, you will find that Indian Meteorological Department starts issuing its statements that monsoon is expected to arrive in India on 1st of June, first week of June, second week of June, last week of May. Till the final week, the scientists or the climatologists are not sure that when is it that the monsoon will come into India? When is it that we'll have the onset of rainfall? So, why is it variable? So the entire aspect of when does it begin to finally rain and when do we say that finally monsoon has arrived, that is driven by the blockage that we observe in the upper atmosphere over India. And that blockage that we observe is in the form of subtropical westerly jet stream. This subtropical westerly jet stream, even though not as strong as a polar jet, nonetheless, it is able to provide that blockage in the upper atmosphere. Yesterday, we had seen in the image that this subtropical westerly jet stream, due to the obstruction offered by the Himalayas, the Karakoram, Hindu Kush, Suleiman, Kirthar, all these ranges, the Tibetan highlands, this jet gets bifurcated into two components. Right? You have the northern branch, you have the southern branch. And listen to this now carefully. Northern branch and you have southern branch. Now, during the change of seasons, we do observe the change in the pressure belt systems. Fair enough? During the change of seasons, as the seasons change from summer to winter, winter to summer, the pressure belts, depending on the temperature on the ground, the pressure belts also will shift north or south. Now, where are these jet streams formed? Jet streams are formed in upper altitude, directly above these pressure zones, almost above these pressure zones. So, with the shift of the pressure zones, you can have the shift of the jet streams as well, right? As we talk about the tricellular model of circulation, there what do we see? If we consider one hemisphere, we observe that this is what you can think about as the tricellular model of circulation. So, these are your different pressure zones. The subtropical high pressure belt, and this is where you will have the jet stream. That is the subtropical westerly jet stream. That is where it will be in existence. Now, if I consider the region of India, during the months of December, January, and February, during the months of December, January, and February, this subtropical high pressure zone, that is, during these months we have winter in India. These subtropical high pressure zone, they will be shifting north or they will be shifting south during the month of November, December, January, February. What do you think? Will they be shifting north or south? Very good. It will be shifting to the south, isn't it? So, as these are shifting to the south, this jet stream will also follow them in a delayed fashion, but it will follow them. So, this jet stream also comes slightly to the south. This also comes slightly to the south. Obviously, The northern branch cannot come south because there are obstructions in the way, physical barriers in the way. So the northern branch cannot come south. But as the rest of the jet stream gets to the south, can we not say that this will empower or strengthen the southern branch of the jet stream? The southern branch gets stronger, right? And the northern branch will get weaker. We can say so, right? Why? Why they shift to the south? Okay, why the jet stream shift to the south or why the pressure belt shift to the south? What is the question? Yes, Rahul. Why the jet streams shift to the south? Okay. Why the jet streams shift? Okay. Where are the jet streams formed? Jet streams are formed above the pressure areas where there is difference in the temperature of the air in upper atmosphere. Now, if this subtropical high pressure belt that you see, if during, I hope that this is clear that during the winter months, the pressure belts will shift to the south. During the summer months, they will come back. So if you have the subtropical high pressure here, that means the winds will be falling over here. As the pressure belts is shifting to the south, that means the cells, they will have a different circulation altogether. Now, will the jet stream be able to remain in its original position now? No. This jet stream will also shift to this place. So that is why with the shifting of the pressure belts, the jet stream also tends to shift. Okay? With the shift of pressure belts. Now is it understood? That is, you had a question by Shivani and Biswajit. Now is it understood that why it is shifting? Pressure belts, the jets also shifts. Now, few of you had a question that why one part will strengthen and why the other part will weaken. That was a question. Now, let us address that as well. So imagine that under normal circumstances, on an average, this is the position of the jet stream. Right? Here in between all of this, you have a large physical barrier which the jet streams cannot simply overcome. It is because of this physical barrier that you have the northern branch and a distinct southern branch. Right? Now, think about it as if this is a flow, right? And you have an obstruction in between. So the flow deviates into two. Fair enough? Now, if the entire jet stream is shifting south due to the shift of the pressure belts, what will happen? What can happen? Think about it. What logically do you think? How will the air tend to behave in that case? One can be that the entire jet stream, as it shifts to the south, the northern branch does not get its required quota of air. The other can be that the jet stream has decided to move to the south, regardless of whatever the physical barrier are in the form of Himalayas, Karakoram, etc. Northern branch decides that it doesn't want to be alone this time of the year. It wants company. So it will cross over the Himalayas and come to the southern branch. That can happen? Absolutely not. So obviously, the jet streams cannot cross over the Himalayas. So if the jet streams are moving and you have a distinct northern and a southern branch, if the main source in itself is moving south, won't the southern branch get strengthened and the northern branch gets weaker? Can that happen? Right? That is why during the winter months, the southern branch gets weaker. Then again, during the summer season, the pressure belts will shift to the north. Due to heating of the land, etc., the ITC says as it moves north, the pressure belts during these months, they will shift to the north. Now, as the pressure belts, they shift to the north, the jet streams will again initiate a journey in the northward direction. The jet streams will initiate a journey in the northward direction. Now, when the jet streams have moved to the north, let's presume, during the summer, during the summer months, the jet streams have moved to the north. Now, out of these two branches, which of them will be stronger? Northern branch or the southern branch? Which of them do you think will be stronger? Perfect. As the jet streams are moving to the north, which branch of the jet stream will be stronger? It will always be the northern branch. Nitesh, that is not the question. The question, seasonal reversal is monsoon. That is not the question, Nitesh. So, the northern branch will get stronger, right? The southern branch will get weaker. Why? Because think about as if this is your obstruction. Let's suppose this is your obstruction, and this is where the winds are coming in. It is dividing into two, right? Now, as the wind will move to the south, the southern branch will get more supply. As the winds are getting to the north, the northern branch will get more direct supply. So, as the jet stream moves to the north, as jet stream moves to the north, the southern branch weakens, right? The southern branch weakens. Now, nonetheless, the southern branch is there. As long as you have the southern branch of the jet stream, means across the central part of India, that is around the region of Madhya Pradesh, Chhattisgarh, parts of West Bengal, even some parts of Odisha and Andhra Pradesh, sometimes even up till the extent of Hyderabad. To that extent, you have a strong obstruction in the air in the form of this jet stream. We then come to the month of May. By the month of May, ITCZ has already come over India. By the month of May, ITCZ is situated somewhere here. But still, you'll find the presence of the southern branch because in upper atmosphere, some channels continue to supply the wind. Southern branch is very weak, but it is there. Now, the ITCZ has shifted. ITCZ has shifted meaning what? Meaning the moist winds, they are coming over to India. Moist winds, they are coming over to India. But the winds won't be able to reach the ITCZ. Why? Because the jet stream is offering an obstruction. Now, few of you, the smarter ones, who are very, very smart, basically, you will always have, obviously have the question. Fair enough, the winds cannot reach the ITCZ. But Kerala is not there. Kerala is very far away from ITCZ. At least Kerala can receive rainfall in the meanwhile, then we will take care of ITCZ. Why is it that even despite the fact that the winds reach there, Kerala doesn't receive rainfall? That is because these jet streams, they offer an obstruction for the entire movement of air. If you think about it, these jet streams. Adeline, my dear friend, yesterday, that is where we had discussed this process in very great detail. about the jet streams, their formation, their generation, kindly take a look at the annotation of the PPT and the recorded videos if you want. You can take a look into that. We have discussed in greater detail yesterday itself. Okay. So here, when you talk about these jet streams, basically form a kind of an air blockage. Right? That means it won't allow the air which is present here to cross this region and come here. Okay? But then the air which is present here, it will get trapped almost. Imagine this to be Hyderabad. Let's assume Odisha. I don't want people to get touchy that how did you say that over Hyderabad, my city, so nice city, you are saying air blockage is there. Did you not see the various awards that Hyderabad has? So let's assume it is Odisha, right? So here you have the air which keeps on getting blocked. Let's assume this is where you have your Kerala. Now, in that entire region, the air is blocked. So here, air is blocked and stagnant. Right? Now, even if moisture carrying winds that we represent here, even if these moist winds come here, will they be given entry into Kerala? No, because there you already have a lot of crowd, isn't it? If think about a room is filled by 20 people. Even if you dress up in a good suit and a proper headphone and everything, still you will not be given entry. Fair enough, when the room is vacant, you can have that swagger and get an entry. But during normal conditions, there is no place for you. Similarly, these jet streams, they offer the air blockage due to which the entirety of the region experiences a stagnation of the air. The air is unable to move even a slightest bit. So wherever the air parcel is, it stays there. The air parcel waits. Waits for what? Waits for the disappearance of the southern branch. Because every passing day, as the heat keeps on increasing in the northern hemisphere, the entire jet stream keeps on shifting slightly to the north. It keeps on shifting slightly to the north. And as it shifts to the north, the connection gets weaker. The southern branch slowly and steadily weakens. This is what the climatologists, they make a prediction of. When you hear the prediction about onset of monsoon, what is it that they are predicting? What they are predicting basically is, when is it that the southern branch will disappear? One fine day, eventually, maybe by end of May, maybe in the first week of June, one fine day, the southern branch over this region simply disappears. What happens? Imagine you are in a classroom where you have the principal or the headmaster or the headmistress, whosoever is there, that person is standing in the classroom and you are supposed to follow discipline. So for the 2 to 3 hours or 4 hours, you have been waiting patiently. Suddenly, that teacher or that principal leaves the room. What happens to the class after that? You have an absolute random motion. Whatever anybody wanted to do, they will do now, right? Because now there is no obstruction. So once this blockage is removed, what will happen to the winds? The winds will be driven in. And that is when, for the first time, the winds will drench the Kerala coastline. And that is when Kerala starts receiving a substantial portion of rainfall, that is when we say that the onset of monsoon has happened. That is what drives the onset of monsoon in India. Sometimes, what happens, that during the month of July and sometimes in the month of September and August, as was observed in the year 2021, I don't know if you will recall it. In 2021, we received significant rainfall in the month of June, July, and suddenly from the later part of August, it started becoming drier. So sometimes what happens during the month of August, later, that is around 18th, 20th of August, right up till first week of September, this southern branch reappears. It reappears due to other atmospheric conditions that we'll not go into, but it sometimes reappears. Whenever it will reappear, immediately the rainfall activity will stop. Immediately. It will follow a 20-day, 30-day dry period, but it will stop. So that is how relevant southern branch of the jet stream is for Indian monsoon. So here, these are the jet streams, that is the subtropical westerly jet streams, which tend to develop over the region of the subtropical high pressure belt. During the winter months, these jets lie over the northern part of the Indian subcontinent, having a distinct northern and a southern branch. With the onset of summer season, as the ITCZ shifts north, the southern branch of the jet stream starts to weaken. Eventually, as it disappears, then the moisture-laden winds come in and they cause rainfall. Okay? Yes, Kivika, that is correct. Shivam, jet streams are formed at tropopause, but Himalayas are below tropopause. Shivam, you had asked this question. I had replied to this question earlier as well. That, see, when you think about the entire aspect, that jet stream is formed at a height of 6 to 15 kilometers or 7 to 15 kilometers. What do you understand by that? That it is not formed at the same level. It is meandering. Himalayas are at a height of 7 kilometers above sea level. And yesterday also I told you it is not going to be the case that Himalayas and jet streams, they are going to somehow accommodate that, okay, 6648 meter, then from 6649 meter you can come into existence. No. Because above the mountains, they will have their own air packets above them. Above them, you will now immediately above the Himalayas, will you find the temperature variation to be that significant? No. So all the conditions have to be present there. Temperature difference in upper atmosphere is very important for the generation of these jet streams. When we say they are formed at tropopause, that is where predominantly you will find the presence of the jets. Sometimes these jets, if I give you the detail, and I hope you don't get confused by it, sometimes the formation of these jets can drive down and up the height of tropopause itself. Because nobody has fixed that, okay, this is tropopause, till the next parliament session, this will be the tropopause. Nobody dare increase or decrease it. No. Wherever you have the difference in temperature in upper atmosphere, it can be at 7 kilometer, 8 kilometer, 9, 10, 11, 12, 13, 14, 15. It will generate a jet stream. Okay? I hope that is clear. These divisions of jets are eddies. Vipin, jets, they do generate a lot of eddies. That is perfect. But this southern branch is not an eddy. In fact, this southern branch, eventually when it meets the northern branch in the region around South China Sea, there it tends to generate some eddies after that, but not this. Okay? Aman, polar vortex is a classic example of meandering jet streams. It is a classic example, yes, absolutely, of weaker jet streams and how they start to meander. So this is about the jet streams and their role. Then comes the role played by the Tibetan highland. and the Tibetan Plateau. So this also, the heating of the Tibetan highland, that is able to generate a temporary jet stream. A temporary jet stream is generated as a consequence, as a result of it. So we'll take a look at this before, but we take a break. And then after that, we come back, we'll talk about the tropical easterly, the temporary jet. Okay, so break. Subtropical westerly jet is a permanent jet. Okay. So 6:45 p.m. Anil, why there is a gap in India, but not in Africa in ITCZ in months of January? It is there. Anil, please don't get that FOMO. Okay, that why only in India? Even in Africa, it is there. See, the image that we have shown, that is not exact, accurate depiction. But then during the months of December, January, oftentimes you'll find the ITCZ in Africa crossing over the Namib and the Kalahari region around Botswana, that is in southern Africa. And during the summer months, you'll find the northern summer months, that is, you'll find the ITCZ sometimes crossing the region of Egypt in a way. Egypt, Sudan, and so on around Sahara. So there's a great continental variation. Okay. Right. So let's take a break. So I will be back by 6:45. Okay. Acha, when is the iftar time today? Accordingly, we'll give break. It is at 6:50, is it? Okay. Accordingly, we'll be giving break. So if it is at 6:50, then fair enough. Can we continue for 10 minutes more, guys? After that, we'll give a break if it is okay with everyone. Can we continue for 10 more minutes? Thank you. Thank you for being accommodative enough. So we'll continue this for 12 more minutes, and then we'll give a break. So basically, we come to the other point. We will understand the other point in the meanwhile, and that is the role played by the Tibetan Plateau in Indian monsoon. Now, this role which is played by the Tibetan Plateau, it is not make or break for the Indian monsoon, in the sense that it is not as if Indian monsoon will not happen. It simply strengthens the Indian monsoon in certain case. Think about it, that you are preparing some material might increase your effort. That is not the main driver of the effort. So the work that it does is, it works to strengthen the Indian monsoon. Strengthens the Indian monsoon. How? That is where the Tibetan Plateau, by getting heated, is able to generate a temporary jet stream in the region that we refer to as the tropical easterly jet. A temporary jet that is tropical easterly jet. Yes, Aman Biswajit, we are extending for 10 more minutes, and then after finishing this, we'll have a break. Don't worry. So, that is where, when we talk about the Tibetan Plateau, they work to strengthen the Indian monsoon. Okay? That is their role. How, why, we'll come to it. But first of all, understand it, that it is not as if the influence of Tibetan Plateau is not there, it is not as if that you will not have the Indian monsoons occurring. But the influence of the Tibetan plateau that further strengthens the monsoon by generating a temporary jet, that is tropical easterly jet. Now here, why is it that it is generated? So basically, these Tibetan highlands, they are the highest plateau across the world, right? They are the highest plateau across the world with an average height of 5,000 meters above sea level. That is the average height, 5,000 meters above sea level. As a result of this, and Tibetan Highland is also made up of dark basaltic rocks. When I say dark basaltic rocks, think about it. When you have the summer season, when the sun is shining, if you have darker rocks that you see, the temperature gained will be higher or the temperature gained will be lower. What do you think? Temperature gained will be higher or lower? Temperature gained will be very high. This is something which is going to get very, very heated up. So the Tibetan highland during the summer season gets very heated up. So heat is gained and lost very quickly by these rocks, and during summer, Tibetan highlands get very hot. Now, what happens as a result of this when the Tibetan highland gets very hot? So here you have to imagine the entire picture if you can. That is, think about it. Let's suppose this is your Himalayas. This is your Tibetan highlands. Let's assume the average height of the Himalayas overall in the, let's consider this to be 7 kilometers. Even though that is not the average height, but still. Let's consider this to be 0 degree, right? Now, as I told you, that the temperature will be very hot. This will create what? A low pressure here. Isn't it? Now, this low pressure will lead to what? This low pressure will lead to rise of air. Air will rise up. Air will rise up. It rises up till where? So the air has already begun to rise at a height of 5 kilometers. Tibetan highland, the average height is 5 kilometers above the sea level. So the air has already begun to rise at a height of 5 kilometers. After they hit the region around tropopause, then what will happen? The air will simply diverge, isn't it? The air, when it hits above, it will simply diverge. If I have to represent it in an image, suppose air is diverging in this portion. Let's suppose the air is diverging here in some portion. Now, when the air is coming up, it will diverge in all directions. It will diverge in all different directions. Isn't it? Now, out of the directions that it diverges in, it is the upper atmosphere divergence that I am representing. Why? Due to extreme low pressure condition created on the ground. Why? Due to heating of the rocks in the Tibetan highland. Why? During summer, these rocks, when they are exposed, they get heated at a quicker pace. So, this upper air divergence that you observe, one of them will go towards the region of Siberia and the region of Manchuria and erstwhile Manchuria, the region of eastern part of China, etc. Here, one which is going to be interesting is the one which travels like this. So it ends up traveling in the upper atmosphere. It ends up traveling like this. After crossing the equator, what will happen to the direction? The direction will change. As the direction changes, eventually it bends to the left a bit when it enters the southern hemisphere. It will experience a change in direction. And eventually, around the region of the southern subtropical high pressure zone, that is where it will sink. Around the southern subtropical high pressure zone. That is when, or that is where it will sink. And when it does sink, what happens as a consequence, as a result of that? As I told you, this high pressure zone is like the main switch driving the monsoon. So they will be driving or initiating very strong winds coming towards India. So more of these upper atmospheric winds means more surface winds moving towards India. That means more that this upper tropospheric winds that you see generated from the Tibetan highlands, more will be the winds driven towards India, isn't it? Now, let us understand it through here. So, the low pressure is created around the region of Tibetan highlands. Then, eventually, after reaching the tropopause, it will diverge. As it diverges, one part simply goes to the south and sinks in the region of the subtropical high pressure zone. Subtropical high pressure zone. Now this will be driving the winds towards India. This is what will be driving the winds towards India. Now, overall, this upper movement of air that you see around the region of tropopause, this upper movement of air happens roughly at around 90 to 100 km per hour. 90 to 100 km per hour. Okay? And this follows a streamlined flow. That is why it is referred to as a jet, because it moves in the region of tropopause. It has a speed of around 100 km per hour and it has a definite streamlined flow. So because of three reasons, it is considered as a temporary jet. Why only temporary? Because during winter season, this will not exist. This will be in existence only during summer months when you have the heating of the Tibetan highlands. It is that heating of Tibetan highlands which has created this low pressure. So that is why it is what is referred to as tropical easterly jet stream. Okay? Right? So that is why it is referred to as a tropical easterly jet stream. And This tropical easterly jet stream strengthens the subtropical high pressure zone. So, stronger the tropical easterly jet stream, stronger will be the winds driven towards India after crossing all the oceans, and that will always be able to bring much more amount of rainfall. So that is what drives more rainfall to India. So understand the chronology of it, after which I will recap it again. Don't worry, understand the chronology of it. During the summer months, these rocks become very hot. They form an intense low pressure region over Tibet as they become very hot. Resultantly, the air rises up and diverges from a height. After that, the divergent air goes all the way to southern hemisphere and sinks over the region of Mascarene High. That is the southern subtropical high pressure zone. This upper air movement is referred to as a tropical easterly jet, and this forms an important cycle to strengthen the monsoon. So don't worry, I will recap the entire thing. We'll take a break till 7 p.m. now. Okay. After the break, I will recap that. Till that point of time, read this chronology. Okay. Pratyaksh, please ask. After the break, I'll solve those doubts. Okay, Pratyaksh? Okay. A confirmation regarding the audio, please. If you're able to hear me out perfectly well. Thank you. So, how meteorological department finds when the jet stream will end? It is based on a simulation depending upon the past features or the patterns indicated by the jet stream. Accordingly, we make an estimate that this is when it will finally disappear. Will there be any change in pressure in areas where air is stagnant due to air blockage? No, overall, there will be a kind of a heating up which will happen, a prolonged heating which will happen, and that will induce a low pressure, but it won't create rainfall because the upper movement of air will be completely blocked. Then, jet streams are stronger in air in the same winter in both the hemispheres or the respective winters. Respective winters are when the jet streams are stronger. Siddhant, can illegal mining activities influence the rainfall patterns in India? Mostly no, because these are very small activities and very small areas where they influence. Yaram City, what is the meaning of mascarene high? It is basically referring to the subtropical high pressure zone. We will study about this as well. Kamalpal, southern branch of ITCZ also causes rainfall? No, it absolutely stops any occurrence of rainfall which happens. Okay. Now, very quickly, let us recap the role played by the Tibetan highland when it comes to the occurrence of the subtropical or rather the tropical easterly jet and causation of rainfall in India. So when we talk about it, basically, and another question which I left, air rises up, why only it diverges from a height? Why not converge? If the air is rising up, Yaram Seti, if the air is rising up, how will it converge after going to a height? As it hits the region of the tropopause, won't it diverge in all different directions? When the air is sinking, can you think about air rising up again after hitting and bouncing back? No, it is where it diverges. So similarly, as think about it as tropopause, air hits it, it diverges and moves in all different direction. Uh, what happens when the pressure to the pressure zones when the Tibetan high land heats up? The pressure zones remain as they are. This is a different phenomena which happens. So what happens in the region of Tibetan highland during the summer is, as the snows would already have melted, the heating caused by the sun, that heats up the landmass. And the landmass mainly constituted of darker basaltic rocks. Now they end up trapping more amount of heat. Now this is happening at an altitude of 5 kilometers above sea level, which is significant. And at that level, if there is so much amount of heat, there is an intense low pressure which develops over the region of Tibetan highland. Now, because of that intense low pressure which develops, air starts getting heated up and air starts to rise up as well. As the air hits the tropopause, there, due to the low pressure, the air has started heating up. The air has started heating up and it has started rising up. As it will hit the region of the tropopause, that is when it will eventually diverge. It will diverge in all directions. So here, think about this to be your representation of upper atmosphere. Upper atmosphere. Okay. Think about this to be the upper atmosphere. So the air which is rising up from that low pressure, that after hitting the upper atmosphere, that is when it will start diverging in all different directions. Now, we are not concerned with the other branches of this divergence. One of these branches in the upper atmosphere, this is upper air movement. Right? So one of these branches that starts moving southwards. So here it starts moving southwards. As it continues to move southwards, it will end up moving significantly southwards. And here, what is the direction it will take? So if you have to imagine the upper atmospheric wind, think about it, that from here, due to the low pressure created on the Tibetan highlands, the winds will rise up. The winds are going to rise up because of extreme low pressure created over the region of Tibetan highland. Now the winds, after they rise up, they will be bending and deviating and diversifying from this area. So these winds, they will go like this, like this. You will also have one branch like this. Now this branch that you see, it is the movement in upper atmosphere. Movement in upper atmosphere. Right? Now this movement in upper atmosphere, here you will observe that there is a distinct movement of air, and this air observes a speed of around 80 to 100 kilometer per hour. That is the speed that they attain. With that speed, they cross the region of India in the upper atmosphere. After crossing the equator, that is when they will bend to the left and they will start to sink around the subtropical high pressure zone in the southern hemisphere. They will start to settle around the subtropical high pressure zone. Now remember, we told that subtropical high pressure zone is the main controller of the Indian monsoon system in general. So this subtropical high pressure zone, which is strengthened, why? Because you will have more air sinking in. So if you have to imagine the cross section of it, this is the air which is moving to the southern hemisphere. It is crossing the equator. It is sinking here. So this subtropical high pressure zone becomes stronger due to sinking air. Due to sinking air. Now, when this high pressure zone gets stronger, means it will start to generate more winds. Stronger the high pressure, more winds are generated from there. So that is where, as this high pressure zone gets stronger, it will start to generate more winds. And these winds, they will try to reach the ITCZ. From the subtropical high pressure, it tries to reach the ITCZ. Where is the ITCZ? ITCZ is located somewhere here. This is where you might have the location of the ITCZ. Now, the more winds are being attracted towards the ITCZ. Now, all these winds which are generated from here on the surface, they are traveling these hundreds and thousands of kilometers above the oceanic water. So if more winds are generated towards the ITCZ, these are your surface winds. These are the surface winds. So if more winds are generated, why more winds are generated? Because this high pressure gets stronger. And that stronger high pressure drives more winds towards India. And more winds means what? They have covered a larger distance over this Indian Ocean, and hence they are bringing more moisture. So more surface winds will always lead to, so you have jets make high pressure stronger, then more winds are driven at the surface, from the high pressure zone. From high pressure means more moisture is brought. Moisture is brought means more rains in India. Okay? So whenever you have the Tibetan highlands, if the Tibetan highlands get very hot, that means the low pressure which will be created will be very intense. Means more air will rise up. Means this tropical easterly jet will get stronger. Means when the tropical easterly jet is stronger, means it will further strengthen the subtropical high pressure zone around the Mascarene Islands, which is also the Mascarene high pressure zone. And that drives more surface winds. All these winds are covering large areas above the water body, and that is where they carry up the moisture, they pick up the moisture, they drop it, and they bring huge amount of rainfall over the Indian subcontinent. So that is the role played by the Tibetan highlands and the tropical easterly jet stream system. So here, during the summer months, the rocks, they become very hot. Which rocks? The Tibetan highland rocks. After the snow has melted in this region, that is when these darker rocks, they are exposed. Majorly the basaltic rocks, they form an intense low pressure region over Tibet. Resultantly, the air rises up and diverges from a kind of a height around the region of tropopause. That is where one part of it crosses the Kolkata Hyderabad axis. That line, that is where in upper atmosphere you will find. So think about Kolkata, think about where Hyderabad is, draw a straight line. So along that axis, the winds, they start blowing. And in the upper atmosphere, they move from northeast to southwest. They eventually cross the equator, sink at the region of subtropical high pressure, that is the Mascarene high, subtropical high pressure. Okay, so they reach there, they sink there, they strengthen the subtropical high pressure. This upper air of movement of air is referred to as the tropical easterly jet. Why it is referred to as a temporary jet? Because here you have an upper altitude wind movement with a certain velocity. Right? So if you have the upper air wind movement near tropopause with a certain velocity of close to around 100 km/h, that is why it is considered to be a temporary jet. This forms an important cycle to strengthen the monsoon, not to generate the monsoon, but to make it stronger. So if this would not have been there, does not mean that monsoon will be lesser. But if it is present, it will be much stronger. Okay, I hope you understand the difference. For example, if you eat during the childhood days, if you remember that despite all the food items that you would consume, you have those energy drinks, right? So those energy drinks that you drink, that makes you stronger. Does not mean that is your entire appetite. It makes you stronger. Similarly, you have the mechanism of the Indian monsoon, which is driven by the high pressure, low pressure systems. It only gets stronger with this tropical easterly jet. Okay, I hope this is clear. But at 30-35 degree north, there is a subtropical high pressure zone. So that zone will shift, Biswajit. If the ITCZ shifts, won't the entire Hadley cell which is created in that tricellular model, that entire process will shift? Okay. So I hope this is clear. When the jet stream is Rohan, when the jet stream is coming to subtropical high pressure zone, are these dry winds? Absolutely, yes, they are dry winds. But after the winds are generated from this high pressure, that is when they pick up the moisture as they cover the oceanic regions. Deepika, as tropical easterly jet streams is formed by heating, then why are we not calling air raises from ITCZ as jets? Because do you have an upper air defined circulation in a particular pattern at ITCZ? Do you have that? You don't, right? In ITCZ, the air simply diverges and moves across in both the directions to the subtropical high pressure zone. Whereas here you have a streamlined movement in a particular direction and gaining a particular speed. That is why it is referred to as a temporary jet. Okay? The southern branch is strong because it's fixed than northern branch. Amit, this does not have a southern branch. This is the subtropical easterly jet. The one that we had talked about having a northern and a southern branch, that was the subtropical westerly jet stream. This is a tropical easterly jet. Both are different, Amit. Okay? And what about the winds attracted towards ITCZ from the northern hemisphere? Most of the winds, Pratyaksh, will be blocked because as the ITCZ, let's suppose, lies here, you will have the Himalayan system to the north. So that is why the northward movement of the winds or the winds coming from the north will be blocked by the Himalayas. If winds diverge in all directions, then why only one jet is created towards one direction? It is not that only one jet is created. You have another jets also created, but they don't influence the monsoon. Jasmeet, the monsoons are influenced only by this particular portion, and it has a definite origin, a definite endpoint. In fact, one of these that moves towards the region of Siberia, that in itself also initiates a temporary jet, and that has an influence on the climate along the Pacific, but then not relevant for monsoon. So that is why we are not discussing here. Okay. Subtropical western jets, their southern branch is stronger because it is fixed. So it is, Amit, not always will you have the southern branch to be stronger. Only when you have the jet stream in the subtropical westerly jet, only when it comes to the south, then the southern branch will get stronger. When the jet stream moves to the north, the northern branch will get stronger. Okay. I hope it is clear now, right? Can Deccan Plateau generate this temporary jet? No. See, the only reason that Tibetan region or the Tibetan highland is able to generate this jet stream is because it is at a height of 5 kilometers above sea level. That is huge. And creation of an intense low pressure at an altitude of 5 kilometers is even more rare. That is not something which you observe anywhere across. That is why here you have a very specific kind of rise up of the air, which is generally not observed in other parts of the world. Okay? Tropical easterly jet, Devansh. Then we have the role played by the Mascarene High. Mascarene High is the subtropical high pressure zone. That is the subtropical high pressure zone. It is present in the southern hemisphere, right? So this is the one which will drive and generate the trade winds which eventually reach India as they try to reach the ITCZ. So this drives the trade winds which cross equator which cross equator and reach India by picking up moisture. Okay? This is where you have the mascarene high pressure region which is created. And this is what will drive the winds. The winds which reach India. Now, the normal logic will tell us that if this high pressure is stronger, means more winds driven towards India. If this high pressure due to some atmospheric phenomena or the other, if this high pressure is weakened, that means lesser winds towards India. That means lesser rainfall received in India, isn't it? So stronger the high pressure, means more winds towards India. Okay. That means you will have better monsoons or more rainfall. If somehow this high pressure is weakened, that means lesser winds will be generated from here. That means the monsoon will be weaker. Okay. So here, mascarene high overall is a zone of high pressure which exists in the region around Mascarene Islands in the southern hemisphere, and hence the region is referred to as Mascarene High. During the monsoon months, when it is winter in the southern hemisphere, this region of high pressure is the source of winds which travel across the Indian Ocean to reach the ITCZ, which lies over India. Stronger the high pressure, more is the rainfall received during the monsoon season. Weaker the high pressure, less is the rainfall received during the monsoon season. Now we come to the role played by El Nino and La Nina. How is it that El Nino and La Nina impact the monsoonal rainfall received in India? Even though El Nino and La Nina is a phenomena which happens thousands of kilometers away in the region of South Equatorial Pacific, but still it has an influence over Indian subcontinent in terms of rainfall. Why? Because if you recall, while we were looking at the circulations created by El Nino La Nina conditions, those circulations had an arm, those circulations had a presence even above the region of Indian Ocean, right? So El Nino and La Nina conditions, basically, they end up influencing the mascarene high pressure area. That is what they influence, mascarene high pressure area. And when they are able to influence in a way, strengthen or weaken the mascarene high pressure area, that is where they can always drive more winds or lesser winds coming to India. So El Nino and La Nina impact the mascarene high. They bring about an impact in the mascarene high. So heating of oceanic waters in the Pacific, which ends up creating the ENSO conditions in the Pacific Ocean, also end up influencing the Indian monsoon. Conditions of El Nino decreases the overall rains received by India during monsoon months. And conditions of La Nina leads to a surplus amount of rainfall during the monsoons in India. Okay. Now, for general studies, even this much is enough. Let me repeat it 100 times that for general studies, this much is enough. Gone are the days when UPSC used to ask a detailed question in the late 90s, in the early 2000s, when UPSC would ask a detailed question from the candidates that explain how El Nino impacts Indian monsoon, and you had to write around 250 words. Now that is not the phase. So even this much information is more than enough for you guys. But let us understand what happens. This is the condition observed during La Nina. Now, La Nina means in the region of Western Pacific, you have low pressure accumulation of warm water. You have high pressure here, right? Intensified Walker circulation. I want you to observe what is happening here in this area. There is a sinking air column around the region of South Equatorial Indian Ocean. There is a sinking air column, isn't it? Now, what will the impact be on the mascarene high pressure? Will the high pressure be strengthened, or will it become stronger, or will it become weaker due to this circulation? What do you think will happen? Easy. It will become stronger. So the high pressure that is around Mascarene Islands, that becomes stronger during La Nina. Which means what? Which means more winds will be driven towards India, isn't it? Which means what? A higher than average rainfall is received in India. So, due to heating of the Western Pacific, there is a creation of low pressure in the region. The air rises up, forms clouds, and after that, there's a divergence in the circulation. The part which moves to the west eventually subsides in the region of Mascarene High, thereby strengthening the Mascarene high pressure. And when the Mascarene high pressure gets stronger, that means it will strengthen the intensity of the monsoon winds, causing rainfall. Now, this is an intensified Walker circulation. That means even in the case of Walker circulation, that is the neutral condition, this will be the same phenomena, slightly less, even under neutral conditions. Even under neutral conditions, you will experience the same phenomena. Same circulation, but intensity will be less. Isn't it? So there will be the same circulation, just the intensity will be less. That means India receives above or average rainfall. India receives average to above average rains. See, La Nina, the basic work that it does is it strengthens the Mascarene high. And what about El Nino conditions? When we talk about El Nino conditions, there you have the low pressure over the region of the central and the eastern part of Pacific and a high pressure over Western Pacific. Now here, as the air subsides, it then will diverge in different directions. Look at the pressure conditions created here. There's a rising air column. What do you think will be the impact on the Mascarene high pressure? Will the Mascarene high get stronger, or will the Mascarene high weaken? What do you think? It weakens, because rather than a high pressure, here you have a rising air column. So the Mascarene high is significantly weakened. And as the Mascarene high is significantly weakened, means lesser winds being driven over to India. So here, basically, the El Nino induces a circulation which eventually weakens the high pressure system in existence in the region of Mascarene high. When you have Mascarene high which gets weaker, then intensity of monsoon winds leads to a shortage of rainfall. Okay? Yes, Sahil. Mascarene High is the subtropical high pressure zone in the southern hemisphere that we are referring to. Okay. So that is how the impact of El Nino La Nina conditions are experienced over India during the monsoon months. Okay. Then we come to the role played by Indian Ocean Dipole. How is it that Indian Ocean Dipole influences the rainfall received in India during monsoon? How is that impacted? First of all, when we say negative or neutral IOD, where is it that the low pressure is created? Western Indian Ocean and Arabian Sea or the Eastern Indian Ocean? In neutral and negative phases of IOD, where do you think the low pressure is created? It is in the Eastern Indian Ocean. Please revise, guys. It is in this Eastern Indian Ocean where you have creation of low pressure. Creation of low pressure due to normal and negative phases. Now, here we have the high pressure, that is the Mascarene high. Then here we have the extreme low pressure in the form of ITCZ. Now, the winds from this high pressure, ideally, the winds from this high pressure, they want to go from here, they want to reach India. That is what they have decided for their future. That will bring rainfall in India. But then these winds, they find out that there is another low pressure developed in a region which is pulling me somewhere, right? So because there is a low pressure created here during the negative and the normal phase, so that will pull away winds which are being supplied from this high pressure. Many of these winds will be pulled over. So as a consequence, what do you have? You have significant amount of winds which are driven here, and you have lesser winds which are existent towards India, because you have significant amount of winds which are diverted, which are attracted towards that competing low pressure, due to which you have intense rainfall which occurs in the region around Indonesia, but you have lesser winds which are reaching the ITCZ or the Indian subcontinent. And that is why you have lesser rains, because there are lesser wind systems going there. What concept of ITCZ, Kavin Raj? So I hope this portion is clear. So because during the normal and the negative phase, what happens is this attracts or diverts winds originating from Mascarene High. As a consequence to it, you will have lesser winds to India. Lesser winds to India means weaker monsoon. Yes, Siddhant. And Vipin, is more winter in southern hemisphere leads to more monsoon? Sometimes, yes, that is true. Okay. So that is what you have as the Gagan, for diverting negative IOD should be stronger than ITCZ low pressure. Not necessarily if it is near enough. if it is nearby enough, it can easily pull off some of the winds, right? And there the distance is more, so the pressure gradient oftentimes gets nullified, Gagan, in the case of ITCZ due to distance. So that is something here, the distance is less, that is why they get attracted here. Okay, so that is what happens when you have a normal or a negative IOD. Now, what happens when you have a positive IOD? Let us understand that. When you have, let's imagine, a condition of positive IOD. I hope I can use this map. So this is the equator, right? Or can I use this map itself? Let's use this map itself. Okay, let's use this map. Sachin, anything which is easier. While watching the video, if you want to make notes, you can make notes. You can ignore that. Anything which is easier, my dear friend. Okay, this is your equator. This is during negative and normal. During the case of the positive IOD, you have the warm waters which accumulate in this area. Okay, you have the warm waters creating a low pressure in this area. Now, if you have an intense low pressure created here, this is the resultant of positive IOD, Indian Ocean Dipole. Now, this low pressure which is created, what will it do? It is formed very close to the portion of the high pressure. So it will start attracting all the winds. It will start to attract all the winds even from the other nearby areas, because there is an intense low pressure which has developed. But then, once the winds come here, they realize that this is not the most intense low pressure. There is another low pressure which is significantly much more intense. So suppose, think about it, the winds have reached here. Now, once the winds reach here, in comparison to point 1 and point 2, which low pressure will be more intense or which will be significantly lower in pressure? What do you think? Very good. It will be ITCZ. ITCZ will be a comparatively lower pressure. So the winds are further pushed and driven towards ITCZ. So what is the role played by one? Or what is the role played by the warm water? If the winds had to go to ITCZ anyways, why did one come into existence and how will it benefit India? Basically, the existence of this low pressure during the positive IOD, not only does it manage to pull all the winds in this area, all the prevalent winds in the area, it also manages to pull the winds from the nearby areas. More winds, as they spend more time above the water body, they will keep on gaining moisture. And all of them are then eventually sent towards India. While it will lead to formation of cyclonic circulations in the region of Arabian Sea, but all these winds are then directed and pushed towards India. So that means this portion of positive IOD or the warm water, it acts like a channelizing corridor of sorts. It provides a kind of a channelizing pathway, that this is the path that you can follow. So that is where the winds follow that, and that is when they move there. Okay, so that is how you have this winds diverting and moving towards the low pressure. Okay, and they will, that means in the positive IOD, means more winds are channelized towards India due to low pressure above Arabian Sea. Okay, I hope now you understand that how IOD leads to increased rainfall, positive IOD, and neutral and negative IOD reduces the rainfall. It is all an interplay around the masculine high pressure and the winds generated. That is why sometimes even if the El Nino, let's say El Nino circulation weakens this high pressure, still the existence of a positive IOD will attract so many winds from around it that it will still not lead to an absolute deficiency. It will lead to a kind of normalized rainfall. For example, what India experienced during 2018. 2018 was an El Nino year. It was supposed to be a deficient rainfall. But the rainfall was closer to average because of the conditions of positive IOD. And also during that time, very importantly, you had the enhanced rainfall phase of MJO lying above this region of Indian Ocean. So you had then two channelizing corridors, all of them sending the winds towards the ITCZ. More winds were driven towards ITCZ. That is why India could counter the impact of El Nino in 2018. Right? So that is how you have this to come into existence. It can also happen that the monsoon has come into play and suddenly a negative IOD develops during the month of August. Suddenly, the amount of rains which are received, that starts to decrease. Okay, so that is how it happens. So these are the overall factors which will influence the monsoons in India. Now let us compile all of them and let us take a look at the entire mechanism. That how is it that this entire mechanism tends to behave. Okay. Low pressure is at the eastern side, in which case, Amit? So in the positive IOD, low pressure is in the western Indian Ocean. Negative IOD, the low pressure is on the eastern Indian Ocean. Suraj, what if El Nino plus negative IOD, significant drought-like condition? Ananya, the only reason for high pressure at masculine is the tropical easterly jet? No. It is the part of the Hadley cell, the tricellular model of circulation that you would have seen, the Hadley cell that you would have drawn. So the subtropical high pressure zones which exist in both the hemispheres, this is a part of the subtropical high pressure zone. Siddhant, how will winds reach India if the positive IOD low pressure has already attracted the winds? That is what I was trying to say, Siddhant. Once the winds reach there, they will find a competing low pressure. So there will again exist a pressure gradient force between 1 and between 2. 2 will be significantly much more intense. That is what will drive more winds and will attract the winds from the low pressure created in the region of Arabian Sea. Pranay, Enzo cycle and IOD becomes, yes, that is true. XY, can we say that due to this much of factors influencing the Indian monsoon, Indian agriculture is called a gamble over monsoon? In fact, the prediction of Indian monsoon in itself is a gamble. Okay. Now that you know it, I hope you follow the news stories which will start emerging from the month of April itself about the monsoon. And this year, it is expected to be the El Nino year. So this year, ideally, we are expected to receive slightly lesser than average rainfall. Because this year, the El Nino is not expected to be very strong. It is supposed to be slightly weaker. So El Nino conditions are predicted to set in from June and July. That is when India will start receiving lesser rainfall. So all I want out of you is be regular in your current affairs, the newspaper reading that you do. You will come across the news stories of the IMD prediction. You will see how IMD goes wrong in most of the cases. You will see later on how IMD comes up with a justification that, see, we had told you that India will receive less rainfall. India received more rainfall. We are investigating. And then they will come back. You know what? You had MJO and a positive IOD. That is why India received. So these things will happen, and they happen every year. Now that you have read this, you can understand the aspect of current affairs as well. Now, we come to the mechanism of the Indian monsoon step by step. So first thing first, what happens is that the ITCZ that starts to shift to the north. The ITCZ slowly and gradually starts shifting to the north. By the month of May and June, the region around Thar Desert of Rajasthan, the northern Indian plains, frequently experience a temperature of 45 degrees plus. So there is intense heat. So here the ITCZ, after shifting north, what it will do? This ITCZ will start to attract the winds. This ITCZ will start to attract winds. Winds from where? Winds from this high pressure will be attracted towards this ITCZ. Isn't it? These are what? These are trade winds. When they come over to the Indian coastline, they take the direction of southwest, right? So these are southwest winds. Southwest winds. Now these winds, when are they coming over to India? When the ITCZ is advancing, isn't it? Slowly and steadily advancing. The ITCZ is advancing. So slowly and steadily, these winds, they start covering the entirety of the country, isn't it? So that is why this is also what is referred to as southwest monsoon. Southwest monsoon, and also advancing monsoon. Advancing monsoon. Okay? But still now, rainfall will not be experienced. There won't be intense rainfall which will be experienced. Why? Because till now, you will have still the existence of the southern branch of the subtropical westerly jet. So you will have the southern branch of the subtropical westerly jet that will be passing through here. This is the southern branch. Now, eventually what will happen is, slowly and steadily, this southern branch starts to get weaker. Very slowly and steadily, it starts to get weaker and weaker. Eventually, one fine day, it will disappear. Once the southern branch of the jet stream disappears, that immediately opens up any blockage in the air which is happening even in the upper atmosphere, even in the lower atmosphere. Suddenly, the air will think about it as if you have a classroom full of children. Suddenly, they have been told that now it is a sports period or it is the end of school. What happens? Anything they want to do, they will do. Somebody will try to run out. Somebody will like to climb up on their desks and do something on their own, isn't it? So the winds, they start behaving randomly and start getting attracted towards the ITCZ as soon as this southern branch disappears. That is when the winds, they hit Kerala coastline and they bring huge amount of rainfall. Huge amount of rainfall is brought. This is generally observed in the first week of June or the last week of May. That is when we declare it's the onset of monsoons in India. Overall, the moist winds which are carried, those moist winds overall, they get divided into two parts. The moist winds which are carried, they get divided into two equal parts, or not equal parts, two parts. Here, The winds which approach from the zone of the Arabian Sea, they are formed what is referred to as the Arabian Sea branch of monsoon. Arabian Sea branch of monsoon. Owing to the shape of the coastline, some winds, as you saw in the wind pattern earlier, some winds they cross over here in the region of Bay of Bengal. Now here you have the mountain ranges in Myanmar in the form of Tenasserim, Arakan Yoma, Pegu Yoma mountain ranges. So these winds, first of all, they will hit the mountain range. They will cause some precipitation here. And then these winds are directed towards Indian subcontinent. Okay? The onset has already happened here in Kerala coastline. Then across the region of the Western Ghats, you will start experiencing rainfall here. This Arabian Sea branch of monsoon divides itself into three parts. All this portion you will find it written in the additional reading material. So don't get stressed that when do I write, why is he not writing, why is he simply speaking. All this is already present in the additional reading material. So here, the Arabian Sea branch gets divided into three parts or gets trifurcated. One part straight away hits the Western Ghats, causes rainfall on the windward side of the Western Ghats. Another part enters the region between Narmada and Satpura. And as it enters the region between Narmada and Satpura, it causes rainfall in central India. Okay? That is the Narmada Valley, or the region between Vindhyas and Satpuras. Okay, if I said Narmada and Satpura, I apologize. It is Vindhyas and Satpuras. That is where you have the Narmada Rift Valley system through which the winds blow. The third part, it starts moving north here. And it is here when they move parallel to the Aravalli ranges. And here they cause rainfall. Where? In the northern part of the country, not across western part. Now, meanwhile, you have the Bay of Bengal branch of monsoon. Bay of Bengal branch of monsoon enters the subcontinent through the region of Bangladesh. Now it hits the Garo, Khasi and Jayantia, causes copious huge amount of rainfall, right? Then after that, it hits the Himalayan region. It diverges. One part enters into northeast, causing significant amount of rainfall. Other part moves to the west. As it moves to the west, it keeps on causing rainfall across the entire territory. Then it meets with the Arabian Sea branch of monsoon, and that is when at the last phase you will have the region of Punjab, Haryana, Himachal. They will receive rainfall at the end. Okay, it takes almost around 1 month for the entire coverage of the country in terms of the monsoonal wind movement. It takes almost 1 month for the monsoon to completely advance. Okay, once the monsoonal system has been set up in the month of early June or half of June, that is when an intense low pressure starts to develop over the region of Tibetan High. That low pressure will lead to rise of winds, rise of air. This air moves in different directions. It generates the tropical easterly jet. Tropical easterly jet. And this tropical easterly jet then drives more winds. Where? To India. Thereby strengthening the monsoon. How will it drive more winds to India? By strengthening the mascarene high pressure zone. So that is how the monsoons advance. Meanwhile, this mascarene high pressure, it can get stronger, it can get weaker, it can get influenced by the role played by El Nino and La Nina circulations. So the role that they play can end up influencing these areas or the high pressure at Mascarene Islands. And once that high pressure is impacted either by El Nino La Nina or by Indian Ocean dipole, it can always influence the amount of rainfall. It can sometimes be countered by MJO, by IOD, ENZO. They can have an interplay amongst each other where they can counter the impact of each other. Excuse me. So they can counter the impact of each other. But overall, if you have to understand that IOD, ENZO cycles, etc., what do they affect? They affect the Mascarene high. Tropical easterly jet, what does it affect? It affects the Mascarene high. All these, they end up influencing the Mascarene high pressure. And if there is a stronger high pressure and a weak and a very low ITCZ, more winds are driven, more rainfall is brought in over the Indian subcontinent. That is how the monsoon behaves. Up till when? Till when will this condition exist? Is it so that we have studied this, so this condition should exist throughout the year? No. Anything which comes has to go back as well. So here, the monsoon system which has advanced has to go back as well. That is when the next year it will come back again, right? The kind of excuses that you make to the kids during Christmas and all. So this monsoon has to go back and then has to come back. Why and how? So let us understand that. Let us understand the retreat of monsoon. In the entire process, while we were discussing about the occurrence of rainfall, if you would have noticed, the eastern coast around the Coromandel coastline, that is the southern part of Andhra Pradesh and Tamil Nadu coastline, this remains dry. Why? Because the winds are parallel to it. There is no wind coming towards the Coromandel coastline. So this region remains dry. When? During advancing monsoons. Advancing monsoons. Why? Because the Bay of Bengal branch is parallel to it and the Arabian Sea branch is unable to reach there because of the Western Ghats. So that is why this portion remains dry. But during the retreat, something different happens. When we say retreat of monsoon, what do we mean by that? Is it like, Simon, go back? Now that monsoon you have come, now we are so fed up with you, please start to go back, and the monsoon packs up its bags and simply goes off? No. It is again a slow process. It is withdrawal of the pressure systems. Why? Due to change in the position of sun, then ITCZ begins its march or its movement to the south. Why? Position of the sun begins to shift to southern hemisphere. Okay. Now the ITCZ starts withdrawing. The ITCZ, which had attracted all these wind patterns. So it is something which is initiated is initiated around 17th to 20th of September. Okay, the entire process of withdrawal takes 1 to 2 months. So it can continue till late October. So roughly around the time of around 16th of September, 16th or 17th of September, that is when the ITCZ starts to pull off. And it starts to pull off first from the northwestern part. And then slowly and steadily, there's a retreat. Slowly and steadily, there's a retreat. So if I were to ask you the question, which is the state where the monsoon reaches the last and tends to withdraw first, what will your answer be? Or which is the region rather, where it reaches last and withdraws first? Very good. It is the northwestern region around Punjab, Haryana, Jammu Kashmir area. That is where the retreat will happen significantly quickly. Okay. So overall, that is how. So imagine if the monsoon has, or the ITCZ in the month of, or around, let's say 25th September, this is the ITCZ. Even it is slightly northern to it, but still. That means the winds which are being attracted will be attracted only up till here, isn't it? That means the portion to the north, they will not be receiving rainfall. You have the central India which will receive rainfall, isn't it? And slowly and steadily, the subtropical high pressure belt of the northern portion, that will also begin to re-establish itself. Overall, if you take a look at the journey is depicted somewhat like this, where on 1st of September, this is where the low pressure is. Observe on 1st of October, the low pressure is here. 15th of October, low pressure is here. 15th of November, and eventually it dissipates, it withdraws. So in that entire process, as it is withdrawing, another interesting thing I would like to point out. So, as it is withdrawing, September, let's suppose October, right? Let's suppose November, let's suppose December, right? Even November, later part of November here only. Now, low pressure system with this ITCZ will be present even in the areas around Bay of Bengal and Arabian Sea, isn't it? You can have a low pressure system which is present here because the ITCZ is present over there. That is why, as the ITCZ starts to withdraw, again during the later half of October, November and December, you will observe cyclonic disturbances, provided other conditions are also held true. If the other conditions are in place, cyclonic disturbances again will develop during these months. They had come to a standstill during later May, June, July, August. You did not have cyclonic disturbance. From late October again, November and December, you will experience the cyclonic disturbance. Now, what will be the direction of the wind here? The direction, the wind pattern in general. If suppose the wind pattern I have to draw, the wind, that is the trade winds, will be attracted towards this. Now these are the winds coming over from land areas. So obviously they will be dry. Now these winds coming over from the land areas, They are dry, means they will not bring rainfall. But then the winds, there will be winds which will cross the region of the Bay of Bengal and they will hit the Coromandel coastline. So that is when the Tamil Nadu coastline receives rainfall during the withdrawal of the monsoon or the retreat of the monsoon, because that is when the winds become onshore at the Coromandel coast, and that is when wind changes direction. Okay, it becomes northeast to southwest. Coromandel coast experiences rainfall. Okay, so that entire process unfolds in around almost 1 to 2 months. By the end of October, mostly, the withdrawal is complete. And sometimes till 1st of November or first week or first half of November, that is when it can continue even 20th, 25th of November, the entire process of withdrawal, that can continue till 25th or 20th of November as well. Okay, that is the withdrawal of monsoon. Now we take a look at another portion which many of the textbooks, even many of the faculty members that you will find, you'll find that many of them, they will tell you that many of the textbooks as well, they will tell you that northeast monsoon and retreat of monsoon is the same. It is not the same. It is different. Northeast monsoon is very different to the retreat of monsoon. What is this northeast monsoon? So, after the months of October, that is in the month of November, December, and first week of January. First week of January, up till this time. Now, where will the ITCZ be in this time? Very much around the region of equator or somewhere about. Let's say this is the ITCZ. Let's suppose this is the ITCZ. Just for assumption's sake. Now, here, yes, south of equator also you can consider, Pranay, fair enough. Now, something interesting starts to happen during these months. That is, the Indian landmass starts to get colder. But the cold waves, they start to come into existence slightly outside India. The cold conditions, they are generated slightly outside India. Where? In the northwestern portion of India. Here. Right? So here, this is a region which is also referred to as the Potwar Plateau. Okay, this is where the Potwar Highland, the region of Khyber Pakhtunkhwa in the region of Pakistan, the southern part of Afghanistan, that is to the west of Jammu and Kashmir and to the west of Punjab. This is where intense cooling or intense high pressure is developed due to very low temperatures. Around last week of October and first week of November, this begins to happen. Now, this high pressure, it is temporary. It is not a permanent feature. This drives the winds. The winds will be driven. These winds will bend to the right, owing to the Coriolis force. One part will still manage to enter the northeastern funnel. And then these winds, they will follow a designated direction. What is the direction that they have? The direction is northeast to southwest. winds. And these will again be hitting the Coromandel coastline. So this area will again receive rainfall. So that is why the region of Tamil Nadu continues to receive rainfall all the way from October, November, December, sometimes even first week of January. So it is a combination of both the withdrawal of the monsoon as well as the existence of this system, which is referred to as the establishment of the northeastern trade winds again. And that is what is also sometimes in the language book of Indian Meteorological Department, if you look at it, that is referred to as the northeast monsoon. Okay, so it is a temporary phenomena which develops in the months of December mainly, but late November, December, and first week of January, till that duration, as the winds they are driven, they generate or they tend to regenerate the northeastern trade winds, and that is where they have a general direction of movement from northeast to southwest. That is referred to as northeast monsoon. Then we talk about breaks in monsoon. What do we mean by breaks in monsoon? So sometimes you would have observed that the rainy season has come in. For the first 3 to 4 days, it has rained significantly in your area. But then after that, for 1 week, there is no rainfall. For 10 days, there is no rainfall, which makes you start to ponder that why is the world saying the monsoon has come? In my area, it is not raining. Where has the monsoon come? So when such gaps occur in monsoonal rain, that is 1 week to 10 days gaps when they appear in the monsoonal rain, that is what is referred to as the break in monsoon. Okay, why do these gaps occur? So these gaps occur because of one of the things, that is you have change in pressure systems, and also sometimes this leads to divergence of, or diversion rather, diversion of winds. How? So for example, think about it. Suppose this is a region, let's assume Lucknow, even though this is too close, and let's assume another place, Allahabad or Prayagraj. Right? Now let's suppose over Lucknow, it has been raining continuously for the past 7 days, continuously. So what will happen to the temperature at Lucknow? Temperature will cool down. Temperature cools down. As the temperature cools down, then what happens? A comparative high pressure develops. Here you will have a comparative high pressure develops. Meanwhile, let us suppose that Prayagraj has not received rainfall for this entire duration when Lucknow was receiving rainfall. So then you have an intense low pressure here. So now the winds carrying the clouds and everything, they will form over here. So that is how, as the pressure systems, they end up changing, they end up rearranging due to the rate of heating and cooling experienced in different parts. The wind systems, oftentimes, they change their alignment as well. Due to this, you have long gaps in the monsoonal rainfall. Again, during those 7 to 10 days, again that region, the region that you are living in, that again gets reheated. Again, it will start receiving thunderstorms and lightning to begin with lot of dry, dusty winds bringing lot of rain along with them as well. So that is your break in monsoon. Then we have pre-monsoon showers as well, something that we experienced recently, or also if you can think about it, during the month of April, last part of March, and sometimes for the first week of May, we experience convectional rainfall. a localized convectional rainfall is received due to excessive heating of the land. So, localized convectional rainfall due to overheating of land. Okay, that is what leads to rains in April and May. Because this is not a part of the monsoonal circulation, it is a part, or it is created due to localized heating and rising up of air. That is why it is referred to as pre-monsoon showers. It is important for the survivability of many crops, for example, jute, etc. They require some amount of water even during these months. So here, when we talk about pre-monsoon showers in different parts of the country, they are named differently. For example, mango showers. So towards the end of summer, there are pre-monsoon showers. Now, these mango showers, they occur in Kerala and coastal areas of Karnataka. They are called as mango showers as they help in early ripening of the fruit by bringing rainfall during the month of April. Sometimes it starts from late March, April, all the way till May. In the region around Bengal and Assam, however, due to intense heating, it creates intense convection and very significantly thick cumulonimbus clouds are created, dark cumulonimbus clouds. They bring huge amount of thunder, lightning event and heavy rainfall. That is why this is also what is dreaded evening thunderstorms. Their notorious nature can be understood from the local nomenclature that is called Baisakhi, a calamity of the month of Baisak in Bengal and Assam. Right? These showers are useful for tea, jute, and rice cultivation. In Assam, these are also referred to as Bardoli Sira in general. Okay? Why there is break in monsoon? Bimal, it is very simple that the pressure regions that you have, those pressure regions, it is not as if let's say over Bhopal there is a low pressure. So for the entire duration of those months there will be low pressure in Bhopal. No. It can happen that nearby Indore might not have received rainfall significantly and Bhopal has received rainfall for the past 10 days. So Bhopal will get colder. As the region of Bhopal gets colder, then where will the rainfall happen? It will happen over Indore, which is still warmer. So there will be diversion of winds. So that is why it causes breaks. Okay. Then we come to the winter season. That is November, December, January, February, when the ITCZ is firmly in the southern hemisphere. At that point of time, look at the region of Mediterranean Sea. Mediterranean Sea, if I name this is the winter months in the northern hemisphere. So if I name this 1 and if I name this 2, during winter season, which of them will be colder, 1 or 2? Yes, Gokul, that is true. Which will be colder? 2, right? Land will be much colder. Land is much colder, whereas this is slightly warmer. Water will be warmer. It will lead to creation of a frontal depression, a creation of a front, because you have warm maritime air mass and cold continental air mass. It will lead to creation of a front. Not only the creation and existence of a front, it can lead to a frontal depression as well. Frontal depression. Meanwhile, the pressure belts during the winter months, the pressure belts have shifted to the south. So you have the subtropical high pressure belt. Subtropical high pressure. Okay. So here you will have the presence of westerlies and also the jet stream that will again come into the picture. Now this frontal depression which will come into existence, it will lead to formation of clouds, various different types of clouds. Now these clouds, they will cause rainfall, but the westerlies and the jet streams, will they be able to carry the clouds? Absolutely yes. So they are able to carry the clouds with them, and the entire disturbance is carried by them. Now this disturbance does not face any significant obstruction on the ground till it reaches the Himalayas. That is when it hits the Himalayas, in the region of Jammu Kashmir, Himachal Pradesh, it will cause intense snowfall. Whereas in the regions of Punjab, Haryana, Western UP, Delhi, Northern UP, Northern Bihar, Northern West Bengal, and sometimes even up till Assam, they can cause rainfall in that entire zone. And these are what? Traveling systems. So let's suppose this system has traveled. But again, the air over water body is warm, the air over land is cold. So again, another disturbance will be created. Like this, multiple such disturbances are created. So if you take a look at it, in November alone, generally 2 to 4 disturbances are observed. Right? In December, you will experience 7 to 10 disturbances. In January, again, 7 to 10 disturbances. In February, 4 to 5 disturbances. In March, 2 to 4. That is why we received rainfall in the month of March in across the northern part of the country. It was because of this traveling system coming all the way from Mediterranean. And sometimes, in rare cases, it extends even to April. That is when 1 or 2 odd incidents can occur. Since this is a traveling disturbance coming from the western side, causing rainfall across the northern part of the country and snowfall in the mountainous areas, it makes winters much more stronger, much more significantly stronger. And these are the phenomena which we refer to as western disturbances. So what are these? These low pressure systems originate over Mediterranean Sea and West Asia and move into India along with the westerly flow. So you have these being carried by the westerlies, carried over by westerlies. They cause much needed winter rains over the plains and snowfall in the mountains. Sometimes it makes the winter much more harsher, but this rainfall received during the month of December and January is significantly useful for the cultivation of certain rabi crops, crops such as wheat and mustard. Okay, here sometimes even jet streams, the subtropical westerly jet, that is the westerly jet, that also plays some part, but sometimes. Okay, that also comes into play. Overall, as you can see, this is how the disturbance ends up traveling, causing rainfall during the months of November, December, January, February, sometimes even March. While if this rainfall is received in December and January, it is helpful for the crops in this region. But then, if the same rainfall happens in March, as has happened, in many areas, the standing crops of wheat have been destroyed. So this rainfall, when it happens, accordingly, it can influence the agriculture. Does not always mean that rainfall is good for agriculture. Sometimes it can be absolutely bad. Okay, so during the winter months, which part of the country receives rainfall? You have this entire part due to western disturbances, and also the portion of Tamil Nadu coastline due to retreat, withdrawal, and the northeast monsoon. This is the annual rainfall pattern. In general, you will observe that as you move away from the sources of moisture, that is Arabian Sea and Bay of Bengal, as you are moving away from the sources of moisture, the rainfall reduces. So rainfall reduces, rains reduce as you move from south to north and east to west. Excuse me. So this is the overall distribution of rainfall. Overall, you will see western part of Western Ghats, northeastern region, Andaman Nicobar Islands, very heavy amount of rainfall. Look at the leeward side, drier area. Look at the region of western Rajasthan, drier area. Look at the region of Ladakh, very, very dry. But near to the water bodies, the regions receive rainfall. Okay, let us take a look at few of the questions before we end it up. So, which of the following correctly describe the phenomena of western disturbance? They are the aggravated monsoon winds blowing from west to east. They originate over the Mediterranean Sea and are carried to India by winds. Their effect can be felt mostly during the months of July to September. They can bring rains only over the hilly tracts of Himachal Pradesh. I hope we don't get this incorrect. Himanshi, that is a phenomena where during the month of October, even though the rainfall has simply stopped, you have the establishment of high pressure. As I told you, the subtropical high pressure belt comes back, it comes into existence. So you have lack of precipitation, lack of wind movement, and a moisture which is already present in air because of the entire monsoon season which has gone through. So that exaggerates and exacerbates the heat which is experienced. That is what we know as October heat. So during that month, you experience more heat because there is moisture, but there's lack of wind movement because of high pressure. That is why. Okay? Very good. Most of you are correct in this. They originate over Mediterranean Sea and carried over by the wind. Okay. Then consider the following statements about the phenomena of El Nino and its effects on Indian monsoon. It occurs in the region of South Pacific and hence has no impact on Indian monsoon. It leads to increased rainfall over Indian subcontinent during the monsoon season. Its impact can be neutralized by IOD and MJO oscillations. Amit, immediately after Holi, there will be showers. Not always, my dear friend, and not in all parts of the country. Okay, it is not all. Is it so that till now in your life, whenever there has been Holi, next day there has been a rainfall? If that is the case, please point out that is something which is very unique. It needs to be covered somewhere. Very good. So here the first is incorrect because it has an impact on the Indian monsoon. Then the second is incorrect because it does not lead to increased rainfall, it leads to decreased rainfall. And the third is correct that its impact can be nullified by IOD and MJO. Okay. Then, with reference to the retreating monsoons, consider the following statements. The Coromandel coast receives heavy rainfall as a result of this. It generally spans over a long duration from September to November. The movement of winds is from southeast to northwest. Ranjan, Western Himalayas, the western part of Himalayas, that is the Pir Panjal range, where you have the Zaskar range, Dhauladhar range, in the region of Jammu Kashmir, Punjab, Himachal Himalayas, that is Western Himalayas. Then Kamalpal, recently we have seen a tornado in Punjab. That is basically the low pressure due to intense heating which has been created, Kamal. Okay. So here, this is again correct. So Coromandel Coast receives heavy rainfall as a result of this. Correct. Generally spans over a long duration from September to November. Again correct. Right? The withdrawal, the retreat. And movement of wind is from southeast to northwest. This is incorrect. During this time, the movement of wind is northeast to southwest. Okay, so this is incorrect. So you have A, 1 and 2 only. So that is basically the overall portion of India's climatic aspect and Indian monsoon. Just manage to revise this. And immediately after the class, I do recommend you to revise this. If you simply manage to get hold of this, and after this you read the books, after this you refer to any material that you want, but let this form your base, and then take a blank map and try to inculcate all those different steps and mechanisms yourself. Once you are able to recount that what happens in May, June, what happens in then September, October, November, December, if you are able to recount the entire mechanism, I guarantee you will never forget this. You might forget everything else. You will never forget this once you have understood the process. So kindly spend some time, allocate some time to study this. Tomorrow we meet again for the last session of climatology. That is where we'll study about world climate and we'll enter into the portion of oceanography. Okay. Leaderboard. Is that okay? So this is the leaderboard. Okay. So I hope you have understood the process of monsoon. And after this, once you read it again, there will be some doubts which will come up here and there. Don't hesitate to ask questions, but revise this. If you need another revision, the recorded session will be there. You can refer to the tablet video as well for the same revision. Once you understood this mechanism, you can always move forward. Okay? Amit, sir, many of the places experience. See, why I asked you, Amit, see, it is not to make fun of anything, but please understand. In the month of March, if the northern part of the country receives rainfall, it is due to an entirely different reason. And if the southern part of the country receives rainfall, it is due to an entirely different reason. The northern part of the country, especially the northwestern part and the northern part, when it receives rainfall during the month of March, it is mostly due to this traveling low pressure system coming over from the western side. And the southern part, when it receives rainfall during the month of March, it is mostly due to localized convection due to creation of low pressure there. Having said that, sometimes in the month of March, you do have areas around West Bengal, Bihar, Jharkhand, and parts of Odisha. They also end up receiving rainfall because of the land getting so heated up, attracting winds from the nearby Bay of Bengal. So you have a variety of reasons. That is why I tell you that it is not as if God has decided that, okay, when is Holi today? This year is the Holi is on 8th, so we'll have to wait till 9th. Let everybody celebrate Holi. We will have showers on 9th. It is not so. It is a part of the larger myth, a larger storytelling. Generally, you will hear in folklore, right? That on 14th of January during Makar Sankranti, this happens. On Holi, this happens. In this month, this happens. So while I'm not discarding the phenomena, but understand from a scientific point of view, if you have to think about, March rainfall occurring in northern India is largely due to the low pressure traveling systems. In eastern India, the reason is different. In southern India, the reason is again different. Okay? I hope that is clear. Now, Devansh, does westerlies carry cumulonimbus clouds? Yes, they do. westerlies along with the help of jet stream. XY northeast monsoon basically is when you have the establishment of the trade wind system, and these trade winds are driven from the region of the northwest, that is around Potwar Plateau. So from there, the winds they deviate right, and their destination is the ITCZ. So they deviate right, and eventually they gain a direction of northeast to southwest, and it is generally observed in the month of December, bringing rainfall to the Coromandel coastline. Pranay, when we make own notes, then how to rectify our mistakes and make it better? When you revise your own notes, that is when you get to realize that, okay, this is a portion that I have missed. This will only come, I hope you understand, after two readings, a couple of readings or three readings. That is when you get to know, okay, this is a portion I could have ignored, or this is a portion I should include. Accordingly, your notes become sanitized. That is what is referred to as sanitization of your notes. Okay. Arjun, directions, if it becomes confusing, always draw it out on the blank sheet with your own pen. You will get some idea. And the naming of the winds is always done based on the directionality of the winds. Okay. Neil, why does this happen that I understand everything, the concepts, but while writing, I fall short of words? That is because many of the times it happens that while we write it, the mind starts playing tricks that you are writing, this is what you will write in the mains exam as well. And you start writing as if that note is going to be given to Prime Minister and the PMO will read that. So you try to make it so very fair and neat. That is when the next word immediately jumps out of your head. So do one thing, rather than writing it in a very fair manner, take a rough piece of paper. In that rough piece of paper, form the chronology of the events. What leads to what? Simple arrow marking or simple arrow marking. You will find that you are able to explain a phenomena. And then it is all about fitting grammatical sentences in between, which comes with time. Okay. Yaram Sethi, please draw like that show direction of westerlies mango showers. See, these are localized. It is not as if they are coming from some area. Mango showers and nor'westers, the Kal Baisakhi, these are localized convectional rainfall. So winds come over to that area, they get superheated, they rise up. In the case of Kerala and Karnataka coastline, the moisture from Arabian Sea is brought up and converted into cumulonimbus clouds, and they bring rainfall. In the case of the nor'westers or Kal Baisakhi, some moisture from Bay of Bengal is brought up and that brings rainfall. Okay. Yes, Rahul. Floods in Jammu Kashmir and Uttarakhand can happen due to western disturbances, but generally it does not, because it brings precipitation during winter months in the form of snowfall. So the floods that occur, that generally happens due to excessive rainfall during the month of July. That is when you will experience floods, not in June, mostly in July. Yes, XY can we arrow mark in mains too? If you are short on time and if you have to save the word limit as well, always you can draw. In general, I would advise you to follow the flowchart mechanism of explaining something in the mains. It is much easier for the evaluator to read as well. Okay. Shravani, I'm parallel reading my optional standard books. Yes, so the portion that Shravani that we have seen here, that is more than sufficient for your optional area as well. I don't think, yes, there are the names of few of the geographers and climatologists that you will have to by heart, for example, Koteshwaram and all. But overall, the concept is the same, even in the portion of optional. And Bimal, after writing, you can always send it to us at IES Live, the text. Do North India receive pre-monsoon shower? Jasmeet, no. Lack of nearby water bodies brings a prolonged heating season. Devansh, the moist air mass that cause winter rains in northwestern region of India are part of the westerlies. They are brought by the westerlies. Yes. Neil, again, we have exceeded time. I kid you not, tomorrow. Okay, so that will be all from my side, dear friends. Tomorrow we talk about the world, global climate. Ideally, I would advise you that the PPT will be with you. Go for a preliminary reading. It is very theoretical. It can turn out to be slightly tedious, the entire exercise, but get a revision of the tricellular model of circulation. Try to go through the PPT in advance a bit. It will better and in a way lighten your task as well. Otherwise, tomorrow we are up for a theoretical session followed by oceanography. So take care of yourself till tomorrow. All the best. Goodbye and have a good night. Thank you.